During the course of the day, we may make projections and other forward-looking statements regarding future events or the future financial performance of the company and the industry. We refer you to the documents the company files with the Securities and Exchange Commission for more information.
Connections. The world is built upon them. When we connect, we learn, we share, we grow. Life moves fast. In order to keep up with the challenges of today, intelligence is key. Intelligence that connects data algorithms with our day-to-day rhythms. Intelligence that delivers precise treatment, unlocking hidden cures. Intelligence that informs teams to make smarter decisions, faster. And intelligence that predicts and protects us from harm. Micron is essential to the world's most inspiring innovations, accelerating the technology that is leading us into the future. The world is entering a new intelligence shift. The connection between compute and memory has never been more essential in bringing intelligence to light. When we connect, there's nothing we can't do. Micron. Intelligence accelerated.
Micron President and CEO, Sanjay Mehrotra.
Good afternoon. This morning when I was driving in, traffic was really bad, and I was getting frustrated, thinking, when will the flying taxis come around and I can be here faster? But then I thought about the day, I thought about the afternoon, and I got excited that after all, the discussion that we are going to have here today, the technologies we are going to talk about, this is what is going to make that vision of the future a reality. We heard on the video, when we connect, we learn, we share, we grow. We are really excited today to connect with you, the leading, the brightest industries, thinkers, researchers, engineers, technologists, and leaders. We are excited to connect with you to share our vision of the future, but also to advance the discussion on technology, to see how this technology will accelerate intelligence and will shape the world of tomorrow. This afternoon, you will hear many speakers who will present you with inspiration and with a lot of thought-provoking ideas. And ladies and gentlemen, on behalf of the entire Micron team, I'm really excited to welcome you here and thank you for joining us today. I hope that when you leave in the evening today, you will walk away with insights into what is ahead, and more importantly, what we all collectively need to do in terms of really making sure that we get there. On everybody's lips today, the core foundational technologies that are shaping our future, artificial intelligence to neural networks, you can talk about it to anybody today. The foundational techniques and algorithms of artificial intelligence have frankly been around for decades. But they didn't get deployed in the industry because they needed to process a lot of data that needed a lot of compute in order to realize the potential of those technologies faster. Over the course of last several years now, the technology has advanced so that hardware is really becoming the essential disruptor. The hardware, a few years ago, it was all incremental CPU performance gains. Today, the GPUs have thousands of processors that enable processing of thousands of threads in parallel, massive parallel computing. Not only that, you have FPGAs that give you configurability to tailor your hardware to the requirements, to the very requirements of your own workloads. And now even the hyperscalers are looking at their own ASICs in order to fine-tune the applications and fine-tune the performance. So really the world has changed a lot in terms of the performance of the GPUs, the FPGAs, the ASICs, the cores that are really truly enabling a lot of the opportunity of AI, the connectivity. We speak about 5G in the future that's making all the connections faster, but also memory and storage, which is absolutely critical. Because as the performance increases for your the CPUs, it is capable of performing now a lot more data. Artificial intelligence requires processing of a lot of data to fine-tune the insights in order to really deliver actionable results. And Micron's memory and storage is certainly critical in terms of what is needed in terms of realizing the potential of artificial intelligence algorithms. If you think about it, if CPU is the brain, then memory and storage is actually the heart that is needed to realize the potential of artificial intelligence. What all this means is that not only in the data centers of today, but billions of devices that are at the edge, that are really looking at data, gaining insights, translating those insights into intelligence, it is a virtuous cycle. Virtuous cycle in terms of data center providing valuable data to the devices at the edge, devices at the edge getting smarter, having more features in them, to become more intelligent and provide the experiences to the businesses, whether it is the smartphone in your pocket, or it is the autonomous vehicle of the future, or it is a data center delivering great value to the businesses, unleashing new business models. This is what all is needed in terms of the virtual cycle. The virtual cycle of data center, devices at the edge, with the backbone of AI engine, is really what is driving and shaping the future of tomorrow. And this is what we mean by intelligence accelerated. Intelligence accelerated is this virtuous cycle of data center, devices at the edge, and artificial intelligence or algorithms, creating the new world that we never had imagined a few years ago. And data, which is in memory and storage, is very much at the heart of these trends. I want to give you a few examples, and you'll hear a lot more of these later today as well, and you will see them in our downstairs experience zone as well. I took a tour there earlier today, and I can tell you it's very exciting. Just a glimpse into what is coming our way in the future of the technologies. First of all, AI in life. AI in life, let me just give you an example of how floods are impacting more than 200 million lives around the world every year. Google, working with Water Commission in India and utilizing artificial intelligence, has set up an alert system that can give people advance notice of where the flood will be, what will the severity of the flood, and obviously it looks at reams of data from historical events, from rain forecasts, from river levels, from terrain, from elevation, and in predicting where the floods will hit and what the severity of those floods will be. So look at this example of everything coming together in terms of CPU compute, which is needed to run all the simulations in real time, in terms of all the connectivity that is needed, absolutely, to really inform all the local people in terms of potential threat of the floods, and of course, all the data that goes into accurate predicting of the trends related to the floods. So this is an example where AI, supported by compute, connectivity, and storage and memory, is absolutely changing lives. In fact, it is saving lives. AI, in terms of healthcare, this is really something I think that touches close to all of our hearts. It matters to all of us, to our loved ones as well. And this is an area where perhaps where there is the most urgent need in terms of AI algorithms to be applied to solve some of the biggest problems that have been left unsolved since mankind started here. Examples are, and you'll hear again a lot of this later on, you'll see it in the experience zone downstairs as well. Look at Stanford, several thousands, tens of thousands of X-rays analyzed for predicting pneumonia. Basically, in radiology and pathology images, imagine analyzing those images, 3D images as well, bit by bit, to be able to diagnose a medical ailment. Of course, this can be more precise than physicians, and today this technology is already being used in terms of assisting experienced physicians with diagnosis of the diseases. And it's not only about diagnosis of the disease, it's also coming up with the patient treatment plans, as well as managing, you will hear later, precision health, which really avoids your doctor's visits and gives you an opportunity to manage your health on an everyday basis so that you get look-ahead capabilities of any health issues that may be developing. This is really mind-boggling. I mean, it's really, truly making our lives better. It's prolonging our lives, making our lives richer. Great application, once again, where AI and, of course, whether it is around cancer research, or it is diabetes treatment, or it is, of course, identifying pneumonia through tens of thousands of chest X-rays, data is central. Memory and storage is key here. AI in business. I don't have to tell you that today, every business is absolutely looking at how it can leverage AI in it to really gain greater efficiencies and to drive greater productivity. You'll hear examples of what we are doing at Micron itself in terms of utilizing AI for our own manufacturing at the company. But in terms of business, what the image you are seeing here is vertical farming. So this is vertical farming in urban areas. This is 100 times more efficient than mainland farming, because here you can have plants that are planted inside the buildings where the light, the water, the humidity, the temperature is all controlled for different stages of the plant growth. You have produce that is produced right in the urban centers, eliminating the supply chain, the challenges that happen in transporting your vegetables and fruits. Right there from your urban centers, you can get local produce. And imagine, this does not need any pesticides. This doesn't need any chemicals. This is really driving healthy and very efficient farming. So if you thought that AI could not be used in farming, here is a great example. Actually, there are startups that are already doing this. The message is, all of these trends absolutely require data. Data is at the heart of all of these trends. And this is what has inspired us at Micron, that after all, the memory and storage products and solutions that we make, that's where all of this data resides. That's where all the data that is needed to realize, to unlock the potential of AI, whether it is in business or in healthcare or in any walk of your life, it's really critical that our memory and storage is able to support the needs of those requirements. So our vision statement of Micron is transforming how the world uses information to enrich life. And the examples I shared with you, those really connect with the vision that we have at the company. And I can tell you that the 34,000 plus team members of Micron, they are excited to bring new technologies, new products at large scale with highest quality to go into all of these applications that are fueling our growth here today. Of course, we are looking at the future and driving the technologies of the future, but this is built on the 40-year history of the company. I'm very excited that this month, in fact, just last week, Micron turned 40. And over the course of 40 years, Micron absolutely has driven tremendous technology and product innovation. With the support of partners like you, with our customers and our supply chain partners, we have been able to grow the company into a $30 billion plus company in fiscal year 18. And this company has been built with tremendous innovation and tremendous tenacity. In fact, in terms of innovation, over the course of 40 years, Micron and the companies that it acquired have contributed approximately 40,000 patents to our industry. This all has come from tremendous amount of capability from our engineers who today are absolutely focused on continuing to drive our technology and research development efforts to take the company to the next level. When I joined the company about 1.5 years ago, I have to tell you, I was really excited and most excited about the technology portfolio of the company. Having DRAM, having NAND, 3D XPoint, NOR, and future emerging technologies all under one roof is really a powerhouse of a company. And having the capability to manage it, whether at the material research, angstroms of layers deposited or etched, or designing chips, managing microwatts of energy spent in any portion of the circuit, or designing systems and solutions such as DRAM and NAND solutions that go into your mobile phones or into data center applications, or building these products at large volume with the highest quality, having all of this under one roof, I believe is unmatched capability in the industry. And we are bringing this to the benefit of all of our partners. We are bringing this to the benefit of all our customers across multitude of industries, building partnerships with them today, and taking it to the next level in terms of working closely with those customers who are really shaping the trends today and understanding their requirements and building our technology and products to meet their needs of the future. These partnerships are extremely important to us. You'll hear from NVIDIA here today, who is an important partner to us in terms of our high-performance DRAM memory. We also have, for major hyperscalers, built customized solutions that leverage our flash as well as DRAM. We work with customers in automotive to bring our flash, DRAM, and NOR solutions to meet their requirements, which you can imagine in automotive, they are requirements that demand highest standards of quality. But these partnerships are key in terms of growing the company. But we also understand that as a company, it's important for us to advance curiosity in the communities around us. And in this regard, Micron Foundation has just launched Advancing Curiosity Grant. And I want to tell you a little bit here about Micron Foundation. It was established in 1999, and the foundation has given more than $100 million since then to the causes that are important to the communities across the globe. In fact, in just last 2 years, this foundation across the globe has given $25 million to support important causes that are important to our team members, that are important for the advancement of humanity across the globe. Today, I'm really proud to say that we are announcing a grant of $1 million through Micron Foundation that will be going toward advancing curiosity in terms of AI applications as in life, healthcare, and business. First, I would like to invite Dr. Ryan Spittler, Stanford Medicine, who will be receiving a grant of $200,000 to drive AI applications in precision health and integrated diagnostics. I will let Ryan himself tell you a little bit more about it. Ryan, welcome, and thank you.
Well, thank you, Sanjay, for the kind introduction and support. So last year at Stanford, we decided to really try to address an unmet clinical need and to look at the healthy population and how can we keep the healthy population healthy for as long as possible. Now, we did this in the form of creating a new center called FIND, Precision Health and Integrated Diagnostics. And in this center, we're doing this in a number of ways. One way is using wearables and implantables, generating streams of high-volume continuous data, taking this data, and then applying data analytics to this to create personalized prediction models and also to help with clinical decision-making. We also are looking at the biomarkers to look at the transition from health to disease. So the better we're able to predict disease early, the better outcomes we can expect to have later if we do end up detecting disease. And finally, looking at precision health economics so that we're actually able to deploy these. And with this contribution, we're really looking to expand upon our existing research portfolio and look at the mental health space. Professor Ian Gottlieb from Stanford University is leading a study for mental health to look at a very important adolescent population that is highly susceptible to depression and suicidal ideation. And so what we're doing is we're creating a variety of data streams, looking at wearables, different types of endocrine, immune, different types of markers, as well as fMRI and structural MRI, combining these into an integrated data set that we can then help to try and predict whether that a potential suicidal event may occur or that their general mental health is in good status. So we're hoping that what we'll be able to do with this is to create more of a proactive as opposed to a reactive response and use this to touch a number of lives, first in this population, but then in the population at large as well. And so we'd like to really thank you for this support and look forward to working together in the future.
Thank you, Dr. Spittler. Thank you, Dr. Spittler. And over the course of the last few months, I have come to know this organization, and I think it is amazing work that this organization is doing, and we are very happy to partner with you and really look forward to some of these research studies and results and diagnoses and treatments that truly will change the lives in the years ahead. The second grant is to Berkeley Engineering, and I would like to welcome Dr. Sujay King Liu, who is the Dean of Engineering at UC Berkeley. And we are supporting here the Berkeley Artificial Intelligence Research Lab. Dr. Sujay. Thank you. So I would like Sujay to tell us about the Bear lab at Berkeley, and we are really excited to partner with you as well.
Thank you so much, Sanjay, and to Micron for your generous support. It's really an honor for us to be here to celebrate the launch of this new fund. So we are really thrilled to partner with Micron to support the Berkeley AI or Research Lab, or Bear Lab for short, which is performing cutting-edge research to advance artificial intelligence for the benefit of society. The Bear Lab actually comprises 35 faculty and 150 graduate students who are working in a wide range of areas pertaining to AI, from machine learning to computer vision and AI safety. One of the things that Sanjay has pointed out so nicely for us today is that this technology, which has been enabled by advancements in hardware, is really going to have profound impact on virtually every aspect of life, certainly the industries, but just the way that people live, work, and play. And so with this tremendous influence comes a lot of responsibility. So one of the things I'd like to highlight that we're doing at the Bear Lab at Berkeley is really the human-centric looking at societal implications of the research that we are doing. So I just wanted to give you a couple of examples. One example is Professor Ken Goldberg. He leads an initiative in humans and robots, and this is looking at human-centric automation. So, for example, some of the applications are in surgery and in advanced manufacturing. So that's just one example. Another example that some of you might have seen is Professor Stuart Russell's research on the threat of autonomous weapons, on the safety of society and the long-term relationship of artificial intelligence and humanity. So Professor Russell last year gave a presentation to the United Nations warning of the dangers of autonomous weapons and our responsibility to act quickly to make sure that we ensure global stability. Also at UC Berkeley, the faculty and the students are really careful to make sure that we bring a variety of voices to the table to ensure a good diversity of ideas as we tackle tough problems to benefit the greater good. So as people are making advances in artificial intelligence, we keep in mind that this intelligence should be inclusive intelligence. So today we are really delighted to have Micron's support, and we look forward to seeing the innovations that come out of the Bear Lab and the innovations that come to benefit our global diverse society. So thank you once again, Sanjay and Micron, for your generous support.
Thank you. Thank you. Thank you, Dr. King, and we are proud to partner with Berkeley Artificial Intelligence Research Center. Again, the goal of our grants is to promote research in AI in new ways that will change the world here. Our grants here, the 1,500,000 of those will be announced today, and the remaining 500,000 we will be inviting other leading institutions over the course of next several months in terms of initiating support for them as well. What I would also like to point out is that Micron is a company extremely focused on diversity and inclusion, and as a result, part of this grant will be directed toward those researchers and those organizations that are supporting women as well as underrepresented groups toward advancing, studying research related to AI. The third grant will be announced later on in the sessions today. So today is going to be an exciting afternoon. We have an exciting lineup of speakers from Microsoft, Amazon, panelists from NVIDIA, Qualcomm, Verily, Visteon, BMW, as well as luminary speaker at the end, which I think will really enlighten you, and I'm really looking forward to hearing from you, Max Tegmark of MIT. So thank you, everybody, for joining us, and let's get started with the program here.
Amazon Vice President of Alexa and Natural Language Understanding, Prem Natarajan.
Thank you all. Thank you for the invitation here, Sanjay and Preston. It's delighted to be here to talk about a topic that's near and dear to my heart and my mind, conversational AI and Alexa. Let me just sure. So all of us dream, right? American poet Langston Hughes said in his poem Dreams, he said, hold fast to your dreams. If dreams die, then life is like a broken-winged bird that does not fly. And many of our dreams in the field of AI are inspired by science fiction. When I say science fiction, for anybody who grew up when I did, Star Trek is sort of an immediate recollection. But we were promised many things in science fiction. We were promised jetpacks. We were promised spaceships. We were promised holograms, autonomous cars. We were promised the future. Right? And some of these dreams are coming to fruition super fast. That is a hologram of Tupac Shakur. That's not Tupac, and it's super high quality. Spaceship, of course, I don't know if you recognize the guy in that picture, but and this, of course, is William Shatner.
Over. Keep it talking.
And Johnny Five.
Talking, man.
Hello, Ziggy. It's about time you got around to me, Dr.
I've been waiting 24 hours.
Can we move on
to
from
find out
the...
where I am, who I am, who you are.
Sorry, the videos are playing asynchronously from the presentation, so I have to... We have a complex signaling scheme, which I think I made too complex. So, yes, I will try to simplify it, right? So science fiction to science fact, Alexa is present everywhere. When I was thinking about what to title this presentation, I thought I would be modest. I would call it Alexa AI Everywhere, right? But we use everywhere in a somewhat commonplace way. It's in the sense that it's everywhere, it's every day, it's every activity. We want it to be your assistant, your companion, advise you on things. Alexa is also capturing and shaping public imagination today, right? You know, when Saturday Night Live does a skit on you, you've sort of arrived, right? And what do I mean when I say Alexa is everywhere? We're Echo devices that are sort of a primary conduit for Alexa, are available in 80 plus countries. Millions of customers use it every day. And localized experiences, super important to us, is delivering localized experiences that are culturally appropriate. Amazon, as you know, is all about delighting the customer. You don't delight the customer by not looking like one of them, sounding like one of them. And so localized experiences are super important to us. So this is where we are. Conversational AI is center stage. It's a reality that has come to fruition. It's where Amazon invented a new niche market in conversational AI with the Echo family of devices. But where did it all start? How did we get here? Started off in a very simple way with character mode interfaces, with graphical user interfaces following quickly. And then the web, which introduced a sense of abstraction to all of this interaction, because now your computer is a window to the rest of the world. It's not just in itself a world. The mobile platform allowed you to carry this window with you. But the advent of voice user interfaces, what we now colloquially call conversational AI, has sort of made ambient computing possible. You no longer need tactile touch. You're going on with your day as usual. You're just talking to your environment, and whoa, the environment talks back to you now. It responds to you. That's a major milestone for us. And so what does Alexa, just like a quick look at the simplified brain, a simplified look at the Alexa brain. So you might start with an utterance that says, Alexa, play Message in a Bottle by Sting. Right. The utterance is captured. It goes in through a speech recognizer. The recognition result comes out. Maybe it's a single result, or it's a lattice of alternate hypotheses. They're then processed by the natural language understanding engine. You identify the intent along with the arguments around the intent. So if you're saying play a song by artist X, maybe it's the play music intent, and the artist X or the song Y is the argument or the arguments. That's then, there's an ER layer or an entity resolution layer that then brings this all together and says, within the package of something we call a skill, delivers this content over to the customer by translating these intents and associated arguments into actions that can be taken by the device, and then you play out the audio content and you deliver satisfaction. Right? So how do we make this happen? This whole thing about Alexa processing all these utterances and producing it out. From a developer perspective, there are two broad frameworks that we offer. One is at the very front end is the Alexa Skills Kit. The Alexa Skills Kit is how you deliver content to your customer and you delight your customer. The second is the Alexa Voice Services. This is how you deploy Alexa itself on your favorite device. The Echo family of devices is one set of devices on which Alexa is deployed, but you can have other devices manufactured by other people that also carry the Echo family, the Alexa voice service, and give you access to all Alexa services. So today, Alexa developers, it's a big development community. In fact, this 325,000 keeps growing. We've run out of time to update our slides fast enough with the growth in our developer community sometimes. Nearly 50,000 skills. many, many different device types, literally thousands and thousands of personal skills. Add to it blueprints, routines. So you can say to Alexa, you can set it up so that you come home and you say to Alexa, good evening or good afternoon. And if you have a smart home, Alexa can be coded to take a bunch of actions like raise the curtains, start your tea kettle, brew tea for you, things like that. Or you're going to sleep, you say, Alexa, good night, make sure all the lights in the home are turned off, the security system is on, etc. And you can see a wide variety of partners have been using this. But consistent with this growth in the number of skills, the number of features that we deliver to the customers and enable a richer end-user experience is a drop in the error rates. Because as you increase the surface area, the VUI surface area, the burden of reducing the error rate becomes greater and greater. Some of these skills are exercised less than others. Some of them are more complex. So what we've put in a huge amount of effort in making sure that concomitant with the rise in the number of skills is a reduction in the error rate so that the customer experience continues to improve. It's not just richer, but it continues to improve in fundamental ways. Growth for Alexa has been driven through these kinds of rapid innovation. Incredible. We're very grateful to all the brands and developers that have adopted Alexa and made it sort of a platform for delivering content to a lot of our users. So this is where we are, right? This is sort of where it started. This is where we are now. Alexa is everywhere. So where next? When we started with Alexa, Amazon made a fundamental promise to its customers that Alexa would become smarter every day. As you interact with Alexa, she will improve. She will become more capable every day. And we have held true to that promise. One example is that graph that I just showed you, where it sort of summarizes overall performance. The error rates have gone down. But we've improved every foundational component of Alexa: ASR, NLU, entity resolution, linking, text-to-speech. But now we are at an inflection point in sort of this capability growth. In addition to improving these foundational components, we need to improve Alexa in different functional areas. We're trying to make Alexa more competent, like she has more proficiency, more competency. A lot of this also has to do with context awareness. If you talk to a particular device, you might want it to behave in a certain way. You talk to it at a certain time of day. You talk to it with certain personal preferences. Each of these, you want it to inform Alexa's response to you. Knowledgeable. We want Alexa to be able to answer more and more questions. I'm sure you all saw this video where our fearless leader said, ask Alexa what is 50 factorial. And actually, people did ask it all kinds of different factorial questions, and thankfully it answers correctly, right? We want to make it more natural. The whole premise here is natural interaction, is that that the cognitive burden is shifting from you to the device. It's not like I've given you a new device, and here are like 5 new buttons. You saw me, right? I was looking to see, and then I said, oh, this large green button must be the one that advances it, right? That's a little bit of a cognitive burden for me, right? But it's fine. It's one I can overcome on the fly, right? But we want it to be natural. I just want to say, next slide. And I would like the next slide to go on. Why do I need to learn how to operate this device, right? Similarly, self-learning. In addition to users teaching Alexa, we would like Alexa to just observe usage and become better. Identify errors, figure out how to transcend those errors, and become better. So I can't obviously go through the whole details here, but I'll give you a quick look at some of the key things that we've been doing. So one, this whole notion of competency is built upon a pervasive, deep learning is just pervasive throughout our system. Sanjay was talking about how the revolution has been enabled through new architectures, new algorithms, etc. So there's a confluence that's happened, right? We live in a very instrumented world. There is access to massive amounts of data. And then for the first time, we're actually able to pump that massive amount of data into our algorithms and learning techniques and produce models and representations that consume all that massive amount of data and produce more complex capabilities. So we're living at this sort of fortunate time where all of these things are coming together. And so deep learning is sort of become the catchphrase that captures all of this together. But deep learning is pervasive throughout the system. We started off, we have lots of data. The Alexa devices are out there in the field. You have lots of compute with AWS. We have storage in AWS, right? Thanks to all the devices manufactured by companies around the world. So we were able to bring all these together and deliver this delightful experience, magical experience called Alexa. But we've not stopped there. As the scale of Alexa grows, we can't keep relying on more and more data, especially if it means more and more annotated data. Annotated data is super expensive. If you want people to annotate data, it takes time and it's costly. So the question was, can we reduce the amount of data that we need to make Alexa perform just as well or even better? So a recent advance in the last 6 months, active learning has led to a 40x reduction in the amount of training data required to achieve the same performance. Yeah, it's not 40%, it's 40x reduction in training data required. The second important advance has been transfer learning. I'll talk about it in the slide. You might have a data-rich domain like weather or restaurant. You've trained your models, you've invested a lot of effort in it, and those features are working just fine. And now along comes somebody who wants to build a skill and says, it's called recipes. So we would like to be able to transfer as much knowledge, as learning as we can from these weather and restaurant models over to the recipe models. And we're able to do that now. The key advantage of these advances is that these improvements happen in the back end. So the skills developers have to do nothing, and they will see a 15-20% improvement in performance automatically with the same skill, because we've just implemented these transfer learning skills. So these are a couple of examples. Moving on to context. More and more in intelligent interactions with devices, with applications, it's about context. Most of the intelligence or the appropriateness in the response comes from a good consideration of context. So I'll give you a simple example. What's Adele's latest soundtrack, right? And then after that, you say, play it. As humans, we do this automatically. And maybe even in the case of a machine, if I say, play it, and it is explicit, it feels like a less challenging. I'll follow up with a different example later where a deeper challenge is also being addressed. But here, we again use deep neural networks. It's called an encoder-decoder architecture. I'm sure there are many people here in the audience who work with these every day. You also don't have to say Alexa every time. You turn on follow-up mode, and it knows that you're continuing the conversation. Second is multimodal context. Many of our devices now have screens. The screens enrich your experience, especially for shopping. So you want to buy a blue shirt. She will show you a bunch of blue shirts on screen. You might go and pick one by clicking on it. You might also just want to say the second one, place an order, and she'll do it. Third is device context. So if I say play Hunger Games or play Lost City of Z, and I'm sitting next to my Echo device, Echo speaker, maybe I wanted to read out the book, the Kindle or Audible book. But if I say it sitting next to a screened device, then I wanted to play a movie. Right? So there are things like this that combine device context and contextual signals. There are just dozens and dozens of them. So I'm just giving you a few examples. Personal context, you might want to say play music. You want to say play my music. But if I have speaker ID, when I say play music, and it knows it's me, right? Maybe I don't have to say play my music, right? So we're using speaker ID both for this and to authenticate folks for doing shopping and things like that, so that the whole goal is to reduce friction at every point. It's to reduce the experience that you're calling a call center and says, please tell us your phone number, and then somebody else picks it up, asks you the same question. We want to reduce friction for the customer. Right? A peek into what's coming in the next few months. One is this Alexa Guard feature. So as you're leaving your home, you say, Alexa guard, and it starts listening to acoustic events, maybe a smoke alarm, maybe a glass breaking, and it will send you an alert to your app on your phone, and then you can take follow-up action as needed. Of course, I mean, despite active learning, we still had to break quite a few window glasses to get the data for this. But there are, thankfully, cultures where breaking glass is lucky. Right? So I come from one of them. Right? Anyway, whisper mode. So Alexa now sort of tracks you. Most of you, when you're talking to someone and you're having a long conversation, you will notice that you start adapting your speech patterns in a certain way, whether it's the prosody of your speech or certain accentuations, to match. Nowadays, for the last several years, it's been like people start using it, and empathic growth in those speech patterns. Alexa is now starting to learn how to adapt to you, your speaking style, not just your content. So whisper mode is one of them. So if you whisper to Alexa, she will whisper back. The important thing is, this is a showcase capability that showcases this ability to understand your style of speaking and mimic it. It's not a heavily feature-engineered thing. This is actually learning the style and mimicking it. This is just an example that is very evocative and is a nice demo. Natural interaction. So when you started off with Alexa, there was a certain set of things you could do. And maybe you can learn how to talk to Alexa in a way that she understands you, or any conversational AI. But as Alexa starts doing more things, the burden of trying to learn how to do or say all of these more things to Alexa in a way that she understands becomes much harder. So naturalness becomes a more and more important aspect of conversational AI as the user surface area increases. So for example, you say, Alexa, I don't know how many of you use it, I use this feature all the time. Remember that I left the drill package in the garage, or remember that I left my keys on the dining table or somewhere else. And then you ask her, where are the keys? Or where's the drill? You don't want users to have to remember exactly how they said it when they enrolled the memory into the device. So you have to do semantic search. All of these are examples that are somewhat simple, so they're relatable. But these kind of semantic queries apply to more complex situations as well. A second example is when we started off, you had to say, Alexa, ask Uber to get me a car. And it's great if you have 4 skills, 5 skills, 10 skills, 20 skills, and at some point your ability to remember all the skills breaks down. Right? And so what you would rather do is say, Alexa, get me a car. And in this case, we blend in all kinds of deep learning along with contextual signals and user preferences to come back and say, here's the car for you. Another thing that's coming up, multi-step request, or it's already been released in one shot. You want to add multiple things to your shopping list, you can do it. The interesting thing here, I guess, is the peanut butter thing. If you have this, it's 2 words, you still have to make sure it's added on as peanut, not peanuts and butter. Right? Slightly more complex is multiple intents. You might want to say, play Hootie and the Blowfish, and turn on the bedroom lights at the same time, and Alexa will satisfy that request as well. Remember when I said it's great when the context you're trying to carry over is explicit, like play it, and you know that it is a reference to something, so you try to go disambiguate it. Sometimes the reference is not so explicit. Is it going to rain in Portland today? And Alexa will give you the weather and say yes or no. And then you say, and tomorrow. And now there is it's all latent. What is the reference to and tomorrow? The next part to it is, what if I then say, and what about Boston? Right? So you need all of these things to come together for satisfying. So there we use probabilistic learning, machine learning to do it. The last thing in terms of machine learning capabilities that I'll talk about is self-learning. And I'll just give you one example. You talk to Alexa, and your way of asking for a music station is play Sirius XM Chill, right? And Alexa, the way the skill was configured or designed, or the data that was used to train, does not know what XM Chill is, or this channel is. So then the user barges in and says, no, I mean play channel 53 on Sirius XM. So the question is, can you use these kinds of information from the user interactions that you have to automatically learn equivalences between different queries. And then the next time a user asks, some other user asks you to play SiriusXM Chill, you can automatically satisfy it without a single user in the loop annotating this error, fixing the problems, etc. So we're already working on these kinds of capabilities right now. So looking ahead, many in the community, in the AI community, talk about the AI stack. So the AI stack is sort of moving up from simple signal processing and data capture and transducing that signal, like speech signal, into speech recognition, etc., moving up to making some kind of intelligent decisions with that data. Which song did you want? What action do you want me to take? Then moving further up into reasoning, helping me with much more complex tasks. And then there is autonomy. Now, off the top of the stack is this thing called automated general intelligence, which is sort of the holy grail of this whole field, right? But we would like to get all the way up to autonomy in the foreseeable future, right? So the example I'll give you is, you might actually want Alexa to help you what to make for dinner. The whole idea here is moving from simple query response type engagements to actually transferring significant cognitive burden from the user to the device. So what should I make for dinner might start with some suggestions. She learns your preferences. Maybe she can connect you with the right kind of things. Maybe it grows into your shopping list, your grocery list, and then the grocery order is placed. It comes in. Maybe it's about travel plans. What's the weather like in Tahoe this weekend? Each one of these exemplifies a super hard AI, a set of AI challenges that need to be solved. So in summary, I will just say that if this is like a bicycle race, we're very much at the start of the race, the start of the Tour de France. But it certainly looks like it's going to be a super exciting ride and a super exciting bike ride. It's a long bike ride. AGI is still a very long ways off into the future, but we're working towards moving up the AI stack. Thank you.
Microsoft Corporate Vice President of Artificial Intelligence and Research, Lily Cheng.
Hey, everyone. That was a great talk. I think I would totally echo that we are just at the beginning. So if you're feeling like you're not quite sure what to do with AI and what it all means for you, I think that's how you should be feeling, because we are really at the beginning. So I am at Microsoft. I've started my career in Microsoft Research, and it's been really great to think about how we can take all of the speech and language, vision technologies that we have and really bring it as quickly and as openly as possible to lots of companies and people and partners who can use these tools to build their own solutions. So I'm going to tell you 3 stories today. The first one is sort of about ancient history. The second one is about this really cool experiment that we've been doing in China that you probably haven't heard of, and just how inspired we are by the ecosystem around WeChat and Chinese culture, and how AI is really taking off in other countries. And then I'll talk about a lot of the tools that we have to offer and how you can use them. So this was probably the first conversational experience. We had this dream, I think a long time ago, that every computer would be able to have dialogue with you. And it's a very primitive kind of dialogue. Thank goodness we've progressed a long way, which is very brittle. But I think we've always had this dream that you could say something to the computer and it could respond to you. And so, fast forward a bit, we came up with this really amazing thing called the web browser. And I think when you think of the web browser today, we were really pretty naive when we said web browser or mobile phone. We really didn't have a lot of the questions that we have when we say we're inventing AI. Like, what is the impact that it's going to have on your company, and how disruptive is it going to be? Well, I think 2 of the coolest inventions of the web browser were really user experience inventions. First, there was the back button. So if you think about your desktop at the time, there is no back button. You can't go back to what you saw last, and there's no home. And back was really critical because you were looking at other people's stuff way more than your own. So it really changed the way you navigate and search and find things, and really helped you look at things not that you created, but things that other people created a lot more. And it's really transformed the way that we share. So if you think of conversation, these UI metaphors, they're kind of different. Because if I said, or you looked at me and you said back, I'd be like, my mind doesn't work that way. I can't really think of what you mean when you say go back in conversation. Do you mean repeat what you just said? Do you mean I didn't really understand? And I would sort of interpret what you said when you said, you wouldn't really say back. You'd say something like, huh? and I would kind of interpret what you said, and then I would either repeat it or clarify. And so even the most simple things that we think about when we think of conversation and dialogue are really different when you're talking and speaking or even texting than they are when you have a screen in front of you and single user, when you click back, you're going to see that thing that you just saw. By the way, when you navigate in a GPS, you also don't tell your GPS back. Time in conversation and time moving in space always goes forward. Like even if you say repeat, I'm thinking time is forward. I didn't teleport back in time and say what I just said, and it's really hard for me to even think that way. So this is kind of a fun example. One of the first things that we saw people doing when we started providing a lot of these conversational AI tools is people have a database. Let's say it's a database of apartments, and they want to be able to do natural language query over that. So show me 2 or 3 bedroom apartments in Kirkland, which is a city near me, up north, for under 600K. That's definitely not here. So that's can't find that. Okay, so you'd be like, what? No. So the dev that was working on this, in search, you're either refining your results, you're narrowing, or sometimes in a query, you don't have enough results, so you want to expand out. So he said, you could say, how do you want to refine this? And you can refine it by region or city or type, and you can have a visual UI along with a spoken UI or cards. And I was like, dude, nobody says refine. They don't even know what that means. You just want it to work for you. You want this to narrow your results or widen your results based on what you think is the right thing. And if you're not sure, you need to ask. So it's just interesting. Even basic things like search. Nobody wants to see 10 search results in a conversational, so you have to be more likely to be right on the first hit. So I just want to say AI sounds really complicated and hard, but sometimes I think the innovations that we're going to have, just like that back button, the address bar, search, they seem so obvious today, and I think we're still at this point where how can we make having dialogue, just like we have as people, easier, better, and a lot of the inventions might be invented by our AI researchers, and we have a lot of those, and lots of companies have a lot of those, but a lot of them might just be experiential and just really different. And I love these examples because I think our goal is that everybody participates in AI. It's not just a few companies who are fortunate enough to have in schools who got a head start. So people, digital computers aren't binary. We don't think in ones and zeros. That really rigid grid of, files on your computer is always kind of irritating to people like me. You kind of want to shake it up because people are messy. And AI is really cool because it's vector-based. It's kind of in its soul a little bit more the way people think, and just like conversation. So that's my first story. My second story, like I said, was sort of started in China, and this I found on the web. I love it. It is fan art of a chatbot that we made called Xiaoice. And Xiaoice, it started as a hackathon project from the Bing team. Xiaoice actually means little Bing, and they released it on WeChat, and it just went crazy popular. Of course, WeChat immediately shut it down, and so you're supposed to laugh there, but you didn't. So we've just been pushing this because I don't know if how many of you know what WeChat is. WeChat is one of the most popular chat apps in China. If you go to China, install it on your phone before you go, because if you don't have your QR code to meet people in business, it's just standard. It's your business card. And pretty much everything that you could possibly want to do, there's an app in China, in WeChat, that is just conversationally enabled. And that's how business gets done. Everything gets done there through WeChat. It's super cool. And this is just a conversation that we had in Xiaoai. So this is a conversation really interesting is we have many, many third-party characters powered by the same conversation engine. So most of you probably don't play Pokemon all that much in Japan, but that's one of my favorite ones. The Pokemon characters are really powered by this engine in Japan. And just like us, a lot of the brands were really interested in engagement. And so we've just been kind of riffing on that and playing with it. So we have many customers and companies, especially in the Far East, in India, China, Japan, that are using this system. And not only is it text-based and voice-based, but they actually are video-based, and it's just really cool. So Xiaoice today has over 660 million users. And again, the engagement is something that we're looking at. How many chat pairs, how long do people spend engaging? What's interesting? And how can we make it more interesting? In China, there are many, like I just thought this was cool because I was looking at all the press on Xiaoice and I was like, wow, I don't even know these publications. So I just want to remind us that even though we are sort of at the epicenter of tech, you know, in the US, there's just a lot happening and we have to keep our eyes out and learn from all the inspiring work that's happening in so many other countries. So one of the things that's different maybe about this goal to really engage people is we are looking a little bit, we've learned that just earlier you heard a lot about single turn conversation or multiple turns. So this is like at the very, beginning of intelligence, because usually if you say something, you expect the person to be able to like remember what I just said. Not like you say something and then I've forgotten what you said. So now we can do multi-turn, which is like I can remember what you said in a session, but we really want to be able to remember not only do you have memory in one session or one sentence and then multiple sentences, but then over time, how do you actually have more memory and history of what people say? And so we're just looking at how we can do this in really interesting ways, and we're just focusing in on conversation itself. So, there's single turn, there's multi-turn, there's kind of ways that you can continually listen as a session, and we're really looking at full duplex conversation where you can interrupt and interact in real time from both sides over time. And so these are just, and probably people would use different flavors of all of this in a really complex AI, but it's just interesting to think about just basic things, right? Can we understand what you're saying, not just sentence by sentence and not just multiple sentences, but like how do we push the envelope and really get better there? The other thing that we're looking at Xiaoice, which is pretty neat, is just this, we kind of call it the empathy model. We could probably have a better name for it. But in a conversation, lots of things are happening. So sometimes you're listening and you're kind of like, like, okay, whatever you're saying. And then you notice somebody says something like, oh, I'm going to go to a college visit. So that's a moment for you to kind of engage. It's not quite a question, but you might clarify with a question. You want to know the situation someone's in. I'm kind of like walking through these. And you kind of go back and forth between all these different techniques of listening, answering, providing more prompts so people might say more and things like that. And so we have a whole classification that we're looking at of just different ways to understand how are people conversing. And then that's more on the chit-chat side, and then we're also looking at deeper, what we might say, skills. So every morning at 9:30 a.m., Xiaoice in China goes through, like, she not only helps you do silly things like count sheep and do math and recognize movie stars, but she's also giving you, like, finance, so you can kind of customize what you like. But we've been really going deep on some of these skills. And it's just been really interesting to see how good can we get on some of these domain verticals, like for her finance skill. She's been doing finance briefings for many, many days, and we're just trying to see how good can we get, how close to human parity can we get, how much can people rely on this, how much should they not rely on it, and so forth. But one of my really favorite things that Xiaoice does, which I think is also interesting, is just would you trust it enough that you would let Xiaoice tell your kid a story? Can we make an AI that will do simple things, make poetry? So in Chinese, poetry is a really, the language is really beautiful, and so poetry ties the symbolism of the language with the way it sounds, melody, songs, things like that. So we're trying to really get at more human things and kind of push the boundaries with show eyes. And of course, she's super famous, actually. She's got like her own TV show. Like I said, she appears in video. She's just kind of there's like a whole thing going on there. So this is, in a sense, our experiment for some AI that Microsoft runs first party to say, like, how far can we push the boundary? Can we take risk? Can we really learn? And then how quickly can we take some of those learnings and make them available to people, to anybody, really, who wants to code and make this their own. But that's kind of my Xiaoai story. The main thing that I would say there is, our goals there are, our long-term vision is if we want to integrate AI into our everyday life, we really need to learn a lot more about modeling human conversation and be pretty open about that and open to experiment. And we have to think not just about getting tasks done, but social skills and emotional skills. Because the moment you have a voice, people attach those feelings to it. And so I think we can do better there. And then just, how does this AI help people have positive relationships? I mean, one of the things that happens with Xiaoai is lots of people in a room will talk to her. Can she understand different voices, react differently, just like a person does if you're a child versus an elderly person, a man, a woman? And, there's a lot of questions that are associated with that of giving AI personality. And then just, again, how do we take all of that, take the things that really work, and really make them robust so that lots of other people can do this for their companies? So this is my third story. We thought initially, I think 2.5 years ago, we launched a product called the Bot Framework, which lets you create your own conversational experiences with open source on GitHub. And we thought that it would be a lot of, open source developers and people experimenting who would use this first. And really, to our surprise, almost every enterprise customer that we work with wanted to integrate AI into their company and really focus on, a younger audience maybe who is used to chatting, and then just wanting to say, like, hey, we haven't designed our company. We designed our store maybe so that people would want to come in, but our web pages, our apps, we didn't really design them as an entry point to our customers. And people don't actually like talking to us that much. It's sometimes you feel like picking up the phone and calling help desk, but often you don't. It's not really a joyful experience. And we want to make sure that if our customers have questions or want to get a new feature, that experience is really personal and exciting. And then on the other hand, we also have Office, and people are like, and by the way, we have all these line of business apps. Sometimes getting work done and sharing information in our companies is just way harder than it should be. Can we use conversational AI as a way to stitch together this stuff that we have? Like, we wish we'd been collecting data in a certain way and built apps in a certain way. Can you help us use AI to build a future? And by the way, we want to own our future. We want to own our data. And, we don't really want you looking at that. It's great that you have your Xiaoais, but we want our own brand and our own company. This is what we're going to build our future on. And so we need to be in control of it. So we've just been having a blast, actually, working with people and understanding what people have and listening to customers. And I think the things that we have as tenants really are that, companies want and should be in control of the user experience and their AI story, control of their data, and obviously their customers, the promise that they make to their customers, and that their assistants really should go anywhere their customers are. And so I think that's really had us think a little bit differently about AI, how we gather data, how we help, how we can build AI that requires less data, how we do things, storing things in your own subscription, and then obviously how things can work globally, because there's a lot of different policy regulations in different countries, and just how do we make sure that any AI system that you're doing, matches all the privacy and security constraints that you need. So I think just we've all experienced while the space is just totally growing. I mean, there are probably a pretty big overlap of our 300,000 developers using our tools and Google's and Amazon's. But it's super interesting to see how many people are using this, how many companies are using this, and just how many people are experimenting and really getting stuff out quickly. So one of the things that we just launched 2 weeks ago at our developer conference is We have a group at Microsoft that will help you build. If you don't have developers in your company, you can come to us and we can either hook you up with service integrators or people at Microsoft who will build an assistant for you. And we basically just took all of the stuff that they do and released it open source on GitHub. So if you want to try your own assistant, you can kind of get up and going with a lot of the solutions that we provide. So basically it lets you create your own assistant that can surface through on many different channels like Facebook or Slack or Skype or on SMS and play through on different devices. And then we have a whole set of skills that people can reuse and leverage, including skills that you make yourself or skills that you've made on other platforms. And we connect that through to the knowledge platform and let you plug in third-party assistants. So a lot of people want to plug in other assistants and other apps. And then we also make sure that all this can run on the edge. So that's really awesome. And then, of course, all of that leverages on our cloud, but you can also put a lot of this on any cloud you want. And so those are kind of the framework and the tools that people are using. And again, a lot of the common pieces are just the ability to create these conversational apps, the ability to do natural language query, speech, language, answer questions, translation. You can use all of these components either to create conversational experiences or to create a conversational app. So I'm not going to go through all this. We have a whole suite of tools, really taking you through planning, building, testing your thing, rolling it out, connecting to your audience, kind of evaluating and really quickly learning through what people really do. And again, I think it is early. And so one of the things that we would encourage you to do is just try stuff out. It's just like back in the day when people were creating web pages. First of all, if you don't have any of these experiences that you use that you think are good, like we really encourage you to try using them. Otherwise, it's like designing a web page, never have seen the internet. It's really hard. And a lot of customers trying AI tools out and conversational tools out, they haven't really used them either. So I think try stuff out. We've designed stuff to be really fluid, and then and really learn from there. We have a lot of customers, obviously, around the world trying things out, and we're trying to pull together a lot of the assets that we have. So we're pretty much all in on open source. GitHub is a great resource, and so we're really working well with the GitHub community. We have Azure, Microsoft Research, which is probably the most open or one of the most open research organizations in the world, as well as a lot of the world data we have through search, work data that we have from LinkedIn and Office, and then just data that you have around your customers. So this is kind of my last slide. So yeah, I think our goal, and maybe all of your goals, is like we hope that in the future there are many, many, many thriving, awesome companies who have been able to do things that with their customers and their businesses that they could never have done without the tools that we provide. And so, we hope there isn't a world in the future where there's only like 4 companies that are AI experts and everybody else kind of has to just use that. So we really encourage you, if you have any questions, thinking about your digital transformation or what you're doing, it's all of our, I think, goal to support a wide number of companies and scenarios. And that really means enabling you to own your AI future, your data, and then making sure your customers have experiences that really live up to the promise of artificial intelligence, which, again, like I said, with the Xiaoi's project and the things that we're doing there, really are more human. I mean, we might say that first slide that I showed you was a dialogue system. We would say it's a pretty bad one, probably, the command line. But in some sense, when you think of the state of the art of assistants today, they're still very, very primitive. And so I think that's actually fine. It's a good way to get started. But we're really excited about this because I believe that in the future, the short future, any experience that you have, if you don't do more with what your user is saying or typing or tapping in your user experience, people will think it's broken. So you don't want to have a broken experience. Today, if you type into your keyboard, if there were no words and autocomplete, it didn't give you your little emoji when you type like birthday and show a little cake. You're like, what's wrong with this keyboard? It's like so dumb. Doesn't understand the word that I might type in, or doesn't understand my name, my dictionary, the words that I use in my company. That stuff is just going to be commonplace. Or autocomplete in search. If you typed and it didn't give you like the most common things that the world is typing in that's relevant with memory of yourself in like 2 letters, you'd be like, this autocomplete search box is just bad. And so we're already using AI. And I think this will just increase as people are using your website, your app, calling you on the phone, interacting with you face to face in your store. If you don't have if you don't do more with people input and make that more human and natural, the experiences will just feel lousy. And so we want to make them awesome. And like I said, I think even when you think the desktop still doesn't actually have a back button on it, and you can't find everything the way you should. So there's lots of low-hanging fruit and ways that we can make our experiences better. And we're really excited to be here. And thank you for being here. And let us know if you have any questions. Thanks.
Micron Executive Vice President and Chief Business Officer, Sumit Sadana.
Is there other intelligent life in the universe? Now, I know some of you may wake up in the morning and read the news headlines and wonder if there's intelligent life here. But let's go back to that question. What lies beyond our solar system? What lies beyond our galaxy? Philosophers and scientists have been trying to come up with answers to those questions for ages. Some Hollywood movie producers have also tried that with mixed results. But we are now getting massive quantities of data from the outer reaches of the galaxy to be able to, for the first time, answer some of these questions. And as we contemplate the cosmic realities, we also can go to the other extreme of the scale, from the interstellar scale to the microscopic and cellular scale inside our bodies. And there are many mysteries to be solved there as well. For example, what causes disease? How do we halt the aging process? Without dying, that is. But just slow it down. Can aging be reversed? There are lots of examples on the human health side that I want to get into a little bit more detail there. And frankly, we could have chosen any number of subjects to talk about AI, but we'll just spend a few more minutes on the human health side. So in order to talk about some of the data and what lies ahead, I wanted to get you to start thinking about the massive exponential growth in data we are all experiencing around us. So I'll use 3 quick examples. Astronomy, I'll talk about human health through genomics, and then we'll talk about YouTube. It's always fun to talk about YouTube. There is a new radio telescope in Australia that is capturing data at the rate of 7.5 terabytes a second. And by 2025, that rate is expected to go up 100-fold. Now, if you look at YouTube, YouTube is capturing data through video uploads, 400 hours of video uploaded every minute. And of course, you go to high density, high fidelity, 4K, lots more data gets uploaded every day, every week, every month. But when you talk about real tough challenges like human health and human genomics, the amount of data we are talking about is just mind-boggling. So in order to show you that data, I would have to really redraw that scale for you. And we are talking about exabytes of data. 1 exabyte is 1 billion gigabytes. And so the scale of data that we need in order to solve some of the most pressing challenges that humanity faces with the help of AI, with the help of machine learning, because this is not really a problem that human beings can solve without these tools. The amount of data that we need to analyze is just staggering. So, diving a little bit more into the world of medicine, this is really a big data problem, as I mentioned earlier. And as we dive into genomics, this is where a lot of the secrets that make us who we are, that make us different from each other, are really hidden. And these are the secret codes that we really need to crack. Now, if you think about some of the numbers there, we have 30,000 genes and 3 billion base pairs. In order to analyze and sequence this data, you have to oversample 30 times to take care of a lot of errors that happen in alignment as well as the sequencing process itself. And that means 5 terabytes of data is needed to properly sequence in detail the genetics of one human being. So you can see how quickly all of this adds up and grows. But the human genes are just the beginning. We all actually have a biome inside our body made up of other organisms, and that's resident in the gut. And indeed, the number of cells in the human body that are human is actually only 1/10 of the total cells in the body. And these 90% of other cells are coming from organisms in your gut that science is just starting to understand. This is what constitutes the microbiome. So why is this microbiome important? There has been a lot of research in the last few years that has shown that this microbiome interacts with our genes and creates conditions of health or disease. And through the use of some primitive AI tools and some early machine learning, scientists have tried to capture the biome signatures of many people who are healthy and many people who have disease, and they have started to figure out that people who have disease actually have different signature of the organisms in their gut than people who are healthy. And this is a very stunning development in and of itself, because now it is possible to tell not just who is likely to develop disease by sampling the biome, but also find cures for those diseases. And some of these cures have already started to take shape. And as these cures have started to take shape, some new discoveries that are astounding have come to the forefront. For example, in trying to cure a disease, one person's biome was transplanted into another person, and it turned out that the recipient's body mass became very similar to that of the donor. And that is what led to this new discovery that our weight and our body mass is controlled more by these organisms in our gut than by our diet. And this completely changes how we think about things. And this also talks through why 95% of the people who are going on a diet end up failing, because when people go on a diet, their metabolism actually slows down, and the body resists that change in weight. And I thought it was just me. But, this is very reassuring. So I have to say that, this is just really the start of what science has been able to find, and there are such promising capabilities that will come out of it. And it is really going to revolutionize the world of medicine. Medicine, as we know today, is very, very reactive. We have people who develop symptoms of disease, go to a doctor. The doctor would, try to figure out what these symptoms mean, create a diagnosis. Sometimes it's wrong, sometimes it's right. Takes a few iterations. Go to a pharmacist. Pretty much the same type of medicine dispensed out, regardless of the fact that we are all different from each other. And then you go to the pharmacist, and the pharmacist takes an hour to give you 10 pills from a big bottle to a small bottle. And you go home and it doesn't work. Sometimes it works. A lot of experimentation. But all of this is very, very reactive. It is very slow. And it is, unfortunately, a one-size-fits-all. The future of medicine, you can call it precision medicine, you can call it personalized medicine, is where a lot of that is done very differently. In that, there is a genetic signature that you have, there is a biome signature that you have, there is an interaction between that doctors understand, and based on that, it is possible to tell what diseases you're likely to get even before you get them. Now doctors have been able to see through these studies of the biome that there are changes taking shape inside your gut months and sometimes years before any chronic disease is developed. And that is a very, very long lead time to have in order to try and prevent that disease or to get a head start in curing it. So medicine is going to go from its current state to being very personalized, preventative, and it is going to be a transformational change. But none of that can happen till we get to a point where all of our DNA, our genome has been sequenced, our biome is understood, the interaction is understood, and a lot of learning takes place about how it contributes to human health. So switching gears a bit, I wanted to now talk about another disruption that we are on the doorstep of, which is the 5G revolution. And really, when you talk about cellular networks, to most people, 5G is just another step up from 4G, just like 4G or LTE was from 3G. Well, the reality is that 5G is not just a faster version of 4G or LTE. It is a very transformational technology, and it's starting to get rolled out within the next few months from two of the biggest carriers. And this is incredible. I mean, much lower latency. And imagine having the speed, the broadband speed of a wired connection that you have at home. Imagine having 10, 20, 30 times that speed delivered over the air to devices. I mean, that is just going to transform how we communicate with each other, how we interact, how we get entertained, being able to download HD quality movies in seconds. And furthermore, what 5G enables is a big explosion in endpoints that you can connect to, which means for the first time we will have true machine-to-machine communication capable networks. And when you have that machine-to-machine communication capability, again, you have created something that really allows for new businesses to be created, new business models to be created, new services to be created, and it gets us to the next level in this AI revolution. And the reason I talk about AI in the context of 5G is because now with this machine-to-machine communication, you're really able to do the inference at the edge. More artificial intelligence capability in devices, not just in the cloud. And that is extremely important to take us to the next level of making AI more pervasive in more devices. So let me give you just a couple of very quick examples. So on the business side, when we look at saving energy costs, that's important to everyone. It's even important to the utilities. Smart metering, very, very pervasive going forward. Machines who are able to call home and request maintenance even before they go down is going to dramatically reduce downtime in factories 75 to 80%. Supply chain tracking for packages in real time will become a reality with these more advanced networks. When we talk about agriculture, making the entire food supply safer, increasing yields on crops using drones and other interconnected devices and sensors. And we talk about mobility. Mobility is already so important to us. But if you think about that future, we are going to now be able to integrate with 5G new capabilities that relate to AR and VR. Now imagine you're looking for a new home or a new apartment, and instead of just looking at a window on the browser of your computer, you are able to actually experience through virtual reality what it is to actually walk through that apartment. It will be actually like being there. There are startups today that are working on visualization of what it will mean for you to look at yourself in the mirror wearing a dress that you're seeing on Amazon or your favorite website. All of that is coming at us at breakneck speed. Now switching to autonomous driving, I mean, this is really the most profound change to the driving experience in our lifetime. And dramatic progress is being made behind the scenes in the advancement of this technology. Some of these headlines here and there, notwithstanding about challenges that these systems face, and there will be challenges, we are making tremendous progress. And the reason this progress is important is because 1.2 million people die every year around the world in traffic-related accidents, car-related, vehicle-related accidents. And many studies show that when autonomous driving is fully implemented, 90% of these deaths are preventable. And that is one of the most profound ways in which technology can really positively impact human life. Now, when you think about all of this AI training workloads that are running in the cloud and trying to create this improved intelligence, what's important to understand is how much the hardware infrastructure is in play in making this new technology work the way it does. For example, if you look at the amount of memory it takes to run a typical AI server versus a standard server, if you look at our projections for 2021, 7 times more DRAM memory needed in an AI training server compared to a standard server. Double the amount of NAND flash, because this is really the raw material that AI ultimately needs more and more of. And we are very excited at Micron because our portfolio, we believe, and as Sanjay said earlier, is the most complete portfolio for AI in the cloud data center. And it spans the entire hierarchy. We have extremely fast DRAM for low latency accesses to data, including our leadership in graphics DRAM and our upcoming products in high bandwidth memory. On the other end of the scale, we have very, very fast flash technology, the lowest cost flash technology in the industry, the most efficient flash technology in the industry, both SATA SSDs that we have already introduced and upcoming introductions of NVMe SSDs. And then we have 3D XPoint technology, which offers much higher density of memory and non-volatility to expand the use of memory in these servers, as well as has the option to be used as very, very fast storage, because 3D XPoint is significantly faster, much lower latency than flash. So it's a really complete portfolio. And if you look at the ecosystem of suppliers out there, there are 6 companies in the world who produce flash, 3 companies who produce DRAM, 2 companies who produce 3D XPoint, and only 1 company which produces all 3, which is Micron. So that is really an exciting place for us to be. Now, going beyond the data center and going beyond just these generic products, we have a ton of exciting technologies that we are working on, including some software that we are showing to our customers can speed up their capabilities in the storage stack by 5x to 8x in terms of performance improvements. Tremendous improvements in our QLC SSDs, which are actually replacing hard drives at very, very compelling price points. And we were the first company in the world to actually introduce a QLC SSD to the market. Now, Micron is a very successful choice for the edge as well. When we talk about automotive, we really have the biggest market share in the automotive business. We are really excited to partner with our automotive customers, especially on their journey towards autonomous driving. And we also have created the world's first 12 gigabit low-power DRAM die. And our low-power DRAM has the absolute lowest power consumption based on feedback from our customers in the industry, which means longer battery life, better user experience for their customers. So moving on, I really wanted to talk about the choice that we are making internally to deploy AI solutions in our own factories, in our own fabs, both in our front-end manufacturing facilities, which manufacture the wafers, and then in our back-end assembly, packaging, and test facilities. And we have deployed computer vision capabilities. We have deployed advanced acoustic sensing devices. Thermographic images are being constantly assessed, and sophisticated programs analyze these details so as to improve the quality of our products, identify problems in the manufacturing process as early as possible. We are generating 5 terabytes of data a day that we are analyzing just from our manufacturing facilities. And the results have been really, really amazing. We have had faster yields ramping to maturity, output increase from our existing tools and facilities, and dramatic improvements in quality that we are able to offer our customers. Now, all of this comes down to partnering with our customers. And we really wanted to thank all of you for being here today. Also wanted to thank all of our customers for the business with us. And we look forward to really enabling the AI journey and the machine learning capabilities that our customers are deploying. But it goes one step beyond that. We also want to partner with startups in the ecosystem and actually help accelerate the development of AI and machine learning capabilities in the industry. And for that, we are announcing today a $100 million investment focused on venture funds that we will be making into startups that are focused on AI and machine learning capabilities. We will be looking forward to not just investing in companies that are creating this future that we discussed, and that other presenters have spoken about, but also bringing the scale and resources of the companies to bear so we can help these companies realize their true vision and the full power of their innovations. Not only with our storage and memory technologies, but we also have some really exciting new memory capabilities that we have had several requests for from our startup ecosystem, and we look forward to working with them in those areas. 20% of this amount is going to be focused towards companies which have leadership featuring women or groups which are underrepresented in leadership in technology companies. And that is our ongoing effort as a company to be driving diversity in the technology landscape. So with that, I just wanted to summarize by saying that the trends for exponential growth in data are very much alive. We spoke about a couple of examples very quickly today. You have heard from other speakers, and you'll hear more in the next few sessions about this. And that exponential data growth is requiring a lot of analysis, a lot of from data to insight to intelligence journey. And that means that a lot of the core products that Micron builds are at the nexus of these important secular growth drivers. And we are really excited with where the industry is going. And we look forward to working with our customers and our partners to deliver on the promise of AI. Thank you.
Ladies and gentlemen, Techonomy founder and editor-in-chief, David Kirkpatrick.
All right. Well, the panel, it's also the panel. I'm here. I'm a journalist. I'm David Kirkpatrick, and I do work with a company called Techonomy, which we started 8 years ago, and we've been doing really terrific conferences for that time. We have an annual event coming up in Half Moon Bay, where Sanjay is going to be on stage. I'll be interviewing him there. Also, Tim Berners-Lee and a lot of other pretty amazing people. And I'm super pleased to be here today, although I got to say, those of us on the stage have a significant disadvantage because we can see the view. And you guys have to look at us. But it's look, there's 2 sailboats out there. Damn it, it's so beautiful here. I love this venue. Anyway, so we're here to discuss AI kind of from a variety of perspectives. We were just talking as we were getting ready to come on how well selected the panel is by the Micron people, because we have 3 distinctly different points of view on computing and what's going to happen with AI. And let me just introduce them from the far end. Keith Cresson is a senior vice president at Qualcomm, whose basic job is long-term chip planning at Qualcomm, which is a pretty interesting job. All 3 of these guys have amazing jobs. Premal Salva is with NVIDIA, and his job is thinking about how NVIDIA's products and software, because we'll find out NVIDIA has a lot of software as well as chips, are used in data centers. So, you have the edge guy at the end, and then you have more the cloud guy in the middle. And then here is the software guy. Tom Stanis is with Verily Health Sciences, which, as you know, is a subsidiary of what they would like us to call Alphabet, but we all still really call Google. And he's head of software there. So that's a pretty great job, and he must be pretty good at software if he's head of it at Verily. So I think that we'll start by just asking well, let me just say what I think we're going to do here. We're going to try to understand where AI is headed through the lens of how AI is going to work. That's really, I think, a good way of putting it. And it's not really about memory per se, but I think memory as a force and a factor in enabling things is sort of going to be woven throughout these comments. I may draw it out, or maybe I won't, but sometimes you'll be able to just understand how relevant it is. And sometimes it'll be irrelevant, but that doesn't matter either. So why don't we just start at the end back there. Keith, when you think about AI as a force in society, as a force in business, especially, and as a force in mobile, which is what you guys do, how big a deal is it?
Well, it's a big deal because we're all here, right? And it's a big deal certainly for Qualcomm. And we introduced, the first hardware specific for AI, first instructions, about 3 years ago in our handsets. About 10 years ago, we started doing research on AI. And over that 7 years from Qualcomm AI research, it took us that long from initial research to put specific hardware in the chip for AI. And we continue to accelerate that, and it's accelerating at a fast pace. And originally, you just had some instructions using the CPU to get some AI performance. But I can tell you right now that just about every smartphone we ship uses AI one way or another. And AI can run in the CPU, but we actually have over 1 billion smartphones today that have AI accelerated. In other words, it's using functions beyond the CPU. And the market continues to grow huge in terms of number of ecosystems, programmers, use cases. And of course, we work, there's kind of two ecosystems. There's the China ecosystem that has their own kind of direction, and the rest of the world. And we support both from Qualcomm. But AI touches most of our functions, whether it's imaging, audio, security, and so forth. And like many of those that spoke this morning, we think we're at the early stages. We have a long way to go.
Just talk very quickly about some of the ways that AI actually is functioning in our phones, whether we know it or not.
Sure. So one of the obvious ones is imaging. And so, if you look at your phone, you have a pretty small lens on the back. Yet many times you can take a better picture than your DSLR camera. And why is that? Part of that's the processing. Part of it is AI being used. AI being used for nighttime, right, to make your picture much better. Or AI used for super resolution. Or AI used when you take a picture to recognize faces and more. The same thing's true with audio, with voice recognition and translation. Security, so when you recognize a virus, you don't just look at the exact signature, you look at the behavior of the virus, potentially on a phone, and many more. So AI, whether we know it or not, it's seamless to most users, but it's prevalent in your smartphone today, and the use cases continue to grow exponentially every year.
Really interesting. Okay, thanks. So Premal, talk about AI from the standpoint of NVIDIA, how NVIDIA thinks about AI generally as a factor in your business, but specifically in the data center cloud world, which is so critical to the computer landscape. How does it function?
So for those of you who don't know, NVIDIA has been around for 25 years now. And we started with the graphics processing. That's where we started with. But in early 2000, we transitioned to doing accelerated computing when we changed the chip architecture. Over the last few years, we've been incrementally adding new capabilities to this architecture. So if you see HPC or high-performance computing, today, the 5 of the top 7 HPC computers are using NVIDIA chips in them. But at the same time, not only the chips, we started building the software for this. And at the same time that we build the software, which we call CUDA, now is very popular for doing a lot of the work in AI and HPC environments. We kind of made it very easy for new developers to come on board, to use these chips and to use the underlying hardware and start building on the HPC and AI software that is there, right? So we are just not a component anymore. We are more of a system. We are an end-to-end architecture where AI is being used. What we're seeing is, as Keith said, and what was said earlier, right? AI is right at the cusp of breaking out. We are seeing it in every field. It is very obvious with vision and with images and with video, but we're seeing it with a lot of natural language processing. We're seeing it with healthcare, and it's being applied across all these different industries, and we have use cases and deployment of the platforms that NVIDIA is building in each of these fields and in the data center itself.
Well, you know, it is interesting and impressive that when we talk in the computer industry, and I've been a tech journalist for, 25 or 30 years, about AI, it's pretty much a given that NVIDIA has an advantage right now, right, in terms of doing the processing for AI in the cloud predominantly. Why is that? Is that because of some of the things you just said, and particularly the degree to which you haven't thought of it as just a hardware problem, but also a software and chipset problem? Talk a little bit about how you think of it sort of in a more macro way.
So it's just not about the chip. The chip is going to give you the processing power that is required, but at the same time, the ecosystem around how to enable the developers to make it easier for them is very important. So we've been thinking about it from an end-to-end perspective. How do you optimize and make it available for everybody so that we made our libraries available to everybody? Anybody can go to nvidia.com and download all the different libraries that are required. We talk about deep neural networks. What are the different deep neural network libraries? What are the different capabilities that are required? And they are all available. And we optimize it across all the different AI applications that are there, whether it is visual, whether it is NLP or video processing, whatever it might be. We are optimizing it and making it easier to deploy it on an NVIDIA GPU.
So part of it really is that you've really had to think through what kind of AI is going to be needed in a variety of application areas, and you've done a lot of the work to enable that.
That is correct.
Yeah. Oh, that's really cool. I mean, especially for a company, we thought of it as a gaming company. I mean, that's how you guys got started. Anyway, so Tom, okay, software, and software at Google, at Life Sciences, it's a big change here, but how big of a deal is AI to you?
Oh, I think it's key to everything we do. Verily is born out of Alphabet, out of Google's knit, and you can see that in everything that we do. Everything starts from data. Our mission is about taking healthcare data and making it so that people live healthier, happier lives. And how do we do that? We use AI through collecting it, organizing, and activating data. Collecting it by building biocompatible miniaturized sensors that sense things about your body that you never knew before. For example, one of the things we build is something called a continuous glucose monitor. This is a device, it's a patch that you can wear that can tell you every minute of the day what is your blood glucose. Which for somebody who has diabetes is life-changing. I wore one of these. I don't have diabetes, but I wore one of these just to try and understand what is this like. And I went and had dinner. I had fish tacos, and you think, oh, I've had flour tortillas in there. My blood sugar is going to go up. It didn't go up that much. And then I went for a run, and it came down. And afterwards, I was still hungry, so I went and I had this bowl of corn chips. And I watched my blood sugar go up 80 points.
Wow.
Right? So this thing that was new about my biology, about the way my body processes food, is something that the data told me that I would never have known. So that's the beginning of it, is starting to collect that data. The second part is trying to organize it in a way that's actually useful. We find that healthcare data throughout the entire ecosystem is spread out. It's in different places. Nobody works together. We need to really bring it together. So we started to look at what would be the perfect solution to this. What would be the future state we'd like to have? So we wanted to create that in a clinical study. So we started a thing called Project Baseline. And Project Baseline is a clinical study that imagines if we knew everything about your health that we could possibly know, from the molecular parts of your genome to the medical imaging of your brain and everything else, to sensors that you wore every day that we moved, to what your health history is and what the electronic health record has to say about you, and even how you feel on every day. If we could bring all those together, how much bigger would that data be, and how would we actually organize it together to answer a question? And that study is running right now.
What's that called again?
Project Baseline.
Project Baseline, yeah. And that is almost like an unbounded project, and you're doing that for 10,000 people now, and that's a 5-year project?
It's a 5-year project, so we can actually watch it longitudinally. How has your health changed? And if you go from a healthy state to disease state, what do we see before that we could actually use as a marker to see? We should have known that you were going to get sick beforehand.
But the idea is, from this study of 10,000 people over 5 years in this multifaceted way, you'll sort of get a baseline that allows you to extrapolate to how healthy people should be, right?
Yes.
And then you can start applying that to all of us in diagnostic tools, et cetera, predictive tools, et cetera. But specifically, how are you using AI? And why is AI so essential to it?
Yeah, so AI comes in, and really the last stage was activating the data to be useful. Let me explain one use case that we've been really deep in. we take pictures of your retina, and by taking pictures of your retina, we can actually predict whether you're going to have this thing called diabetic retinopathy, which is a horrible thing that happens to people with late-stage diabetes where they can go blind a very short amount of period of time. And it's totally treatable. There are surgeries that can be done that can halt it before you go blind. But if you don't know this is going to happen, it can be horrible. So we actually have an AI algorithm that looks at your image of your eyes and can actually determine whether you need to be referred to a specialist or not. And we've written a paper about this. It's going through all of the regulatory pathways necessary to prove that it's safe and effective, and will really be something that changes the way that medicine happens with AI. And this is not just the future thinking. This is actually being developed now.
Wow. Okay, so since you're the outlier software person, I want to ask you a question that I want both of you also to answer after Tom talks about it. And that is, because this is one of the things that's really cool about this session is to have a really senior person from, the top processing company at the edge and the top processing company at the cloud. Because the interesting thing I've learned in part from prepping for this panel, but I sort of knew, is that one of the reasons we are poised for this incredible leap with AI is that we are getting these capabilities both at the edge and in the cloud, and then they will both work together and separately. So how is that a factor in the way you are thinking about building your systems and your solutions? And then I'd like each of you to just talk about how you think about that general trend.
Yeah, so, data has to be collected at the edge, first of all, right? And the data that we're collecting today can only be made possible by these amazing devices that are in our pockets that I think are the medical device of the 21st century, your cell phone. The ability to actually take pictures of things changes the way we think about so many problems, and our ability to actually apply AI is possible because of all those sensors. So that really is really important for the edge. But then at the same time, when we do the hardcore AI training, where we're building the models that really understand deep understanding of human biology, that's going to happen in the cloud. That's where we're actually going to have these massive capabilities to work on giant data sets across huge populations of people. So we need the cloud for that. But then eventually, that model has to go back to the person and actually do something to change how their healthcare is being managed. And that's where it actually goes back to the edge. And we have to think about retraining or even potentially transfer learning to understand what does this mean for you in particular. So I think it's actually both.
Wow. Well, either one of you, pick up on that.
Yeah, so just as he was talking about it, right, so as Tom mentioned, there are two things that's happening in the AI world. The first thing is the training portion. That's where you need massive amounts of compute and massive amounts of data to go build your models or build your application that you're talking about. And then taking that application and then compressing it and bringing it to the forefront as an inference. So you'll hear things like training and inference, and these are the two aspects of deep learning and AI that are very important and very different. The first part is where all the magic is happening. That is where we are building the software that does the predictability, that does the identification, that takes data that is labeled, that takes a vast amount of data, vast amount of compute, vast amount of power in the data center and builds this particular software. Then we compress it and take it to the edge. Edge can be anything. It can be a phone, it can be a drone, it can be the Alexa at home, right? So that's what...
Watch.
A watch, exactly. It can be any of these devices that we are compressing and using it. And those are very low power devices. So you're going to figure out all these things in the various life cycle of AI and how it fits along the way. That's where NVIDIA is helping, is we not only do the training portion, but we also help taking these models and then compressing it, bringing it, making it much, much smaller, and bringing it down to the edge devices.
But now, in a mobile age, you're not building the edge devices.
No,
So you need, in a reality, did you guys know each other before?
No.
No.
Do you think maybe down the road you will have to know each other more?
We've had a few conversations between our companies over the years. So
Yeah, because, clearly, that's one of the interesting things. You're going to need to be working together more and more. Is that extreme? Is that wrong? Is that likely?
Never know.
Yeah, I think we're not trying to imply anything here, I don't think.
How competitive? No, I'm not saying. Hey, look, Broadcom was going to try to buy you.
Yeah.
That's something else.
It's always exciting. Every day is exciting. But, more and more data, more and more computing for training, no doubt about that. And there's a lot of server infrastructure. If you look at the amount that's being spent in CapEx right? Look at the amount that Amazon, right? They're spending, what, $20 billion a year in CapEx, right? And Microsoft, Amazon, et cetera, all in the billions. I think the top four are like 60 billion, right? So enormous amounts being spent. A lot of that's going towards AI. On the client, so we're focused on the client. You know, we have chips that go in about half the smartphones worldwide. So about 700 to 800 million smartphones worldwide has Qualcomm chips in it. And we also have chips that go in automobiles, chips that go in IoT, and so forth. So our goal is we're trying to maximize the capability for processing, including inference, on the edge, right? So we're going to maximize it on the edge. And we want to maximize or optimize the connectivity to the cloud. So bandwidth and low latency, right? That's what we're trying to do to connect to infrastructure. And so our view is on the edge, just about every device that computes will also communicate, will also be intelligent. And those devices are limited in multiple ways. Maybe they're limited in form factor, limited in power, limited in cost, etc. So within the envelope, whether it's your phone, your car, or your thermostat or whatever, we want to maximize that capability at the lowest power point, power level, so that AI can be done on the edge. And when necessary, that inference can then communicate seamlessly to the cloud. I mean, that's what our goal is. But I think there's a synergy, right? Whether we talk to each other or don't talk to each other, we're trying to maximize what's done on the edge. NVIDIA, of course, is maximizing what's being done in the cloud in terms of processing.
Right. But, in terms of what's happening at the edge, I'm thinking there's sort of two other technology trajectories that are very relevant to your ability to do that. One is memory. We're here at a Micron event, and the fact that you're going to have memory associated with the processor at the edge, because you can't do every AI query back in the cloud, especially when connectivity is weak, etc. That's one thing. Am I right?
Yeah, there's no doubt. Yeah, more data means more memory.
I mean, that was just a statement, but then at the same time, we're heading into this 5G age, right? Where we're making a leap toward a new kind of wireless connectivity that is lower latency, higher bandwidth, more multifaceted in its capabilities. Talk about what that means to you and what you think, why AI gets sort of even more sort of on steroids because of that.
Yeah, so if you go back in history a little bit, 3G was introduced in 1999, so 20 years ago, roughly. And when 3G was introduced, you had the 3G, and 3G gained in speeds over time, as did the capability, right, of computing, better processors, better cameras, better graphics, etc., and new applications arose. Then 4G came out, and the exact same thing happened. So 4G came out 10 years after 3G, and 4G brought new capabilities. So, Netflix or video or Uber or whatever the case may be, because, again, you had new capabilities. And so there's a synergy between communications and computing, right? And the big jumps in communications come in cellular land about every 10 years. And so now we're 10 years after the first 4G networks, which were in 2009. We're right on the doorstep of 2019. We're in the first half. The first phones will come out with integrated 5G functionality. So that's the communication side. And then what's happening on the computing side is, every year there's improvements in CPU and GPU, etc. But the AI processing capability is growing exponentially. And so if you combine 5G, which was talked about earlier, right, the latency, bandwidth improvements, etc., designed not necessarily just for people, but for machines and things, and you take that, you combine it with a AI processing that's growing exponentially, then you enter into a really exciting time. And that's why I think the description is we're kind of at the early innings, or we're on the cusp. We're not there yet, but we're laying the foundation for a pretty compelling future.
Wow, that was good. So I'd like to ask both you guys, when you look at AI in 5 years, what are we going to be able to do that we can't do now? You're allowed to guess.
So let me tell you what I can do today.
Okay.
Anybody have cats? Anybody love cats? You're going to hate me after this one. One of the best practical examples is this summer I worked with my daughter, trying to teach her about AI and to teach her about what it does. And the application that I came to is basically we have a lot of cats in our neighborhood, and they just want to take a poop right in our backyard, right? And the best application for AI out there was I figured out a way to use something that's available online to take a shot of the cat, use the software at the edge, and fire the sprinklers every time there's a cat in the backyard.
Wow.
Isn't that amazing?
So when you're a technologist, you can do some pretty cool stuff. But okay.
So that was something that is effective today. Maybe
that's not one we rehearsed, by the way.
Yes, yeah.
Okay.
But from 5 years from today, I probably want to come back here, but not drive myself. I want to do exactly what Sanjay said: flying taxis. That might be something very interesting in 5 years. Maybe we can get there.
Yeah, a lot of people think that's going to happen in 5 years, which is kind of scary. What about you, Tom?
I think the thing that I'm most excited about, this is a little bit not as cool as finding cats that are pooping in my backyard, but being able to understand how disease progresses in an objective way. Today, there's many diseases like Parkinson's disease, like MS, where the way that you determine how bad your disease is, you go to a doctor and they try and evaluate you for hours and try and figure out, put you through a series of tests. If you could actually have AI be able to tell, oh, actually this week you're much worse than you were last week, and we see that you progressed this much, oh, and you changed your medication. That medication is clearly not working for you based on this data and what I'm seeing. You need to go and change your medication. We need to try something new. I think that's a big difference in the way that we actually treat disease, to be able to react more quickly and more precisely to how things are doing. And I think that's coming in 5 years.
Gee, I just hope you can break through some of the stasis in the medical establishment, because there's a lot of stasis in the medical, which you implied before about the data incompatibility problem, which is so huge. So good luck with that. Thank you for trying.
We're going to win.
Look, we're rooted for you, definitely. I mean, I don't know how many executives of Epic there are here, but anyway, that's an in-joke, but not a joke. What about one of the things that I was kind of coming up in our prep conversations, people don't know, and it was interesting when Keith was going through the ways that AI is functioning in our phones. Consumers, they hear about AI, they don't know that they're using AI now. Do we need, or does everyone in this room who's basically functioning as a consumer need to know, or will they know when AI is functioning and changing their life? I'd just be curious, any of your comments on that, because it's obviously a central part of the future of computing. But how much do non-practitioners need to be thinking about it in these terms?
So I think for the most part, we all want it to be seamless, right? And so, AI is not a specific technology like imaging or like audio or like something else, right? AI is ubiquitous, right? AI crosses a number of different functions. And I don't think necessarily the user has to be conscious that I'm using AI now versus I'm not using AI. But I think slowly, as AI is applied, users start to see a different type of behavior. You get in your car, and by the way, you can argue whether this is AI or not, but you get in your car in the morning to drive to work, and one day something pops up and says, hey, it'll take you 30 minutes to get to work. It's like, how do you know? How do you know I'm going to work? Or when I'm at work and I leave at whatever evening, o'clock, it'll say it'll take you so long to get home, or you should try this other direction. Or, hey, here's a picture that there's a friend in the background that you haven't contacted, or whatever. Or a lot of the things, Amazon spoke earlier, things you get through the device in your kitchen or in your home. So I think over time, a lot of things will just become seamless. Where at the same time, I think it's important that users be aware of what AI is. Because just as we talked about conveniences and, cars, traveling and, ADAS, etc., there's also downsides to AI. Like, can I believe everything I hear? Or can I believe everything I see? It's because digital data can be manipulated so seamlessly. So I think in terms of conveniences, it becomes seamless. But I think an educated user base in general is valuable, because then you can start to shape your opinions on what AI can and cannot do. Some things are wonderful, like for medicine. Some things aren't, right? On like deceiving others, or, here's a picture of your kid doing something nasty that never really happened.
Mel, what do you think of that?
I kind of agree, right? One of my pet peeves is recommendation engines. Today, everything I see on Netflix is 98% I'm going to watch it. And I kind of don't believe it anymore because it's gotten, I know what they're doing about it. They're using AI for it to figure out what you're more likely to watch. But it comes down to an individual and what bias that they have, whether they consider AI to be their friend or their foe, right? And I feel that where we're going towards is, as you said, it's going to become more and more ubiquitous.
Okay, I'm going to do something unfair and ask you a question about Google that's not verily related. Okay, so we all use Google Maps, probably 95% at least of people in this room use it. It's uncannily accurate at telling us, I mean, in New York, it can distinguish, and it's accurate for mass transit, it's accurate for walking, it's accurate for driving. I mean, it blows my mind, it's scary, and I always think, no, I'm a fast walker. No, it's accurate. How much would you say AI is in the background of that? Just guessing, you don't have to necessarily know, but you do work at Google.
You want to know the percentage of AI that's determining how fast you're walking?
Well, roughly. I mean, I'd be curious any thoughts you have on it.
Yeah, so I mean, it's certainly part of the algorithm.
It is part of it.
Yeah, certainly. I mean, everything that we do is based on looking at what users are doing and then trying to use that to improve the end result of that. Even search is about this, right? So we talk about how we recommend search queries. That's based on what people type. This is even before the whole notion of crazy deep learning AI that was today. There was search query completion. So it is definitely part of all of these things is AI, and you've been interacting with it for many years with Google, and you didn't even know it probably.
But it is interesting that AI as sort of a meme, as a subject of conferences for memory companies, is a fairly new development, right? I mean, AI was not discussed with the sort of aggressive, obsessive way that it's discussed in every computer conference now. So, something shifted in the last few years. I don't know if I'm asking a question, but what shifted?
Yeah, I think some of it is that it became superhuman in some ways. One of the things we did is, I talked before about how we could look at pictures of your eye and tell whether you had this eye disease and things like that. Well, one of the things we did was we tried to do the same thing, and then we actually paired it with people's risks of having heart attacks. No doctor can tell you from your eye picture of your eye whether you're going to have a heart attack, but the machine learning is actually pretty good at it. It actually can predict with pretty good certainty how likely you are to have a heart attack by looking at a picture of your eye. How is that possible? That it can learn something that even humans don't know. And the fact that it's starting to have these applications that boggle our minds that we can't explain, I think that's what's really exciting.
Interesting. I think I did separate prep calls with the three of these guys, and two of them said something to the effect of Moore's law is dead, but things are going to continue moving even faster. So, Pramal, you're the, kind of most Intel competitor kind of person here, though both of them clearly. But what do you think Moore's law is dead, and what does it mean?
Absolutely, right.
But you don't worry about it.
I don't, because we have alternatives, right? Today we have GPU-based servers, the ones which I work on. We can replace a row of servers, 200 servers with one system, and it can give you the same amount of performance that 200 racks of servers would give you, right? And that replacement itself tells me is that what you can do with that with Moore's law, right? Moore's law says that transistors are going to keep doubling every 18 months. Then a few years ago, again, he himself, Moore said it's more like 2.5 years, and now Intel itself is saying it's getting longer and longer. The idea that we can keep shrinking and getting the same performance, or increasing the chip die and getting the same performance out of it, or better, is kind of moving away. And what we are seeing now is we need alternatives. We need a way to increase the performance by using things that are not just the Intel CPU, right? And we have alternative ways of doing it. And we are providing those capabilities.
And to sort of, in summary, journalistic language, it's the software, it's the middleware, it's the chip, and it all working together, right?
Correct.
Okay. Do you agree with that?
Very similar, yeah. I think the idea of Moore's law, of course, is, if you have a given design, a given hardware design, and that every 18 months, every 24 months, you get a certain gain out of it, right? In terms of power, performance, area, cost, right? All four of those vectors. Well, clearly, you're not getting a doubling every 18 months anymore on all four of those vectors. So some of the vectors are still true to some extent. You get to a new process node, things do shrink.
And we do have 7 nanometer chips shipping now, and I think you're doing those, right?
Yeah, we did announce our next chip will be on 7 nanometers.
Yeah.
So there is you can fit more transistors in a given area, and there is some power benefit. Costs are difficult because you get a shrink, but it's a lot more expensive to build the foundries and so forth for more advanced fabs. And performance, you're getting a little bit, but not the material gains you used to get. And so there's aspects that are definitely beneficial on silicon, the silicon treadmill continuing, right? And that's why, for example, Qualcomm is on the leading edge on our performance chips. It's important to go there. So it is important to go to leading process nodes, but it's more for power and area than some of the others. Now, because you're not getting gains in all four of those vectors, exactly what was stated by Premal, you need to be more careful in not having the same design that you just rely on transistors to get you there. You need to change the design. And so you have different purpose-built cores.
Like he was saying about all the different AI apps.
Right, whether it's GPUs or a purpose-built AI engine or a matrix multiplier or whatever. So at the hardware level, you need a different architecture that's more purpose-built. And you can do that for AI, and we as an industry are getting smarter and smarter on how to accelerate that for AI. And then you build the software on top of that, right? And then you build algorithms on top of that. And then you build the data on top of that. And you take that whole package together, and that whole package together, all the way from hardware accelerators to being smart about what you're doing with data, allows actually faster than Moore's Law performance advantage for AI, at least for today and for the foreseeable future.
So that's Preston's law?
Don't. I try and keep my name off as much as possible.
I got a bonus question. Okay, we have 30 seconds left. And most people here don't know, I wrote a book about Facebook, and I'm sort of obsessed with Facebook, and obsessed at the moment with the problems that Facebook has introduced into the world that it hasn't solved and isn't seeming to be about to solve. But Mark Zuckerberg always says, when he's asked, which is not often enough because he doesn't come out of his glass office very much, but that AI is going to be the solution to the disinformation, fake news. So you're 3 AI experts. Quickly, do any of you or do all of you think that AI will be the magic bullet to solve Facebook's problems?
I don't think there's any right answer to this question.
Wait, say that again.
There's no right answer to this question.
Why?
Because if I say yes and then I'm wrong, wow, that's not so good. If I say no and I'm wrong, I'm also in a pickle.
Well, but when you hear him, everybody's heard him say that, right? Does it sound right to you, Premal?
I think it depends.
Okay, that's 2 for 2. Okay.
I could see where an economist would say that instead of an engineer. And it's no offense to anyone, but it's almost like if you have a network that's scaling substantially, more than 2 billion users, et cetera, and news and everything scaling exponentially, and you have to somehow filter that with human brain power, it's very, very difficult to do.
Right.
So almost by necessity, you need to find a way to automate that. And that's why I said that's something that a business person or an economist would do, although I think an engineer would say, this is going to be, this is a tough one.
Yeah. Okay. So, well, that was interesting. Like I said, I have a conference in a month. I wish I could just take these exact same 3 guys and put this session on stage at my conference because it was a really good conversation. So thank you to all 3 of you. Thank you. Really good.
Thank you.
What we're doing with artificial intelligence today is kindergarten related to what is possible.
It is exciting as we see this new technology really start to be used across science and technology, science and engineering, but I think that we are just at the cusp.
I think when you look at artificial intelligence workloads, the first thing that comes to mind is the prominent role that data plays. And since the data sits resident in our memory devices, it starts to become obvious that we have a very important role to play.
Just think about it. We're basically developing the process technologies. We're designing the products to make these computer chips and components that go into all these AI applications. We basically are the building blocks of it all.
Today, AI infrastructure is largely dominated by islands of data. And Micron is able to converge these islands of data and make it a composable infrastructure that is able to fit and adapt to diverse AI applications and enable these applications to scale out elastically.
If we're going to improve the performance and if we're going to reduce the energy of computation, we need to move the CPU closer and closer to the memory. Optimally, being in the same device's memory would be perfect.
Now at Micron, we've pioneered what we call CMOS under the array technology. This technology allows us to place those adjacent circuits underneath the memory array. This gives us a great opportunity to include additional functionality on the NAND flash device that will expedite the execution of any artificial intelligence workload.
Our NAND components have thousands of optimization opportunities. And depending on what the application is, you optimize the NAND differently to make it fit into that application and meet that customer's needs.
So that means if we need to provide additional features within the memory component, it's within our solution space. If we need to add new transistor capability within the silicon process technology, that's also within our solution space. And it really gives us the opportunity to pinpoint exactly where the innovation can happen to provide the least cost addition and the greatest performance benefit.
We have different memory technologies, DRAM, NAND, flash, 3D XPoint, as well as emerging memory.
So really Micron, as one of the very few companies on the planet that has memory storage technologies under one house, has a critical role to play for AI.
Many of the unsolvable problems that exist today will be solved by this type of technology. And the impact that it will have is nothing short of revolutionary.
I kind of think that within all that data, there's a cure for ALS. Within all that data, there's a cure for Parkinson's. At Micron, we're focusing on that because we really do want to use technology to enrich life on the planet. And we can do it with technology in a way that nobody's ever imagined before.
Ladies and gentlemen, Micron Corporate Vice President of Technology Strategy and Operations, Linda Somerville.
Those were my amazing colleagues, and what you just heard was a great intro to the journey that I'm going to take you on today. So my role today is to talk about Micron's memory technology and what we're doing to address high-demand applications in AI. Think about all the data that's been digitized over the years on a variety of subjects from various sources. We need to be able to access and analyze that data with speed and accuracy to get to the answers faster. This is where memory comes in. So the message I want to convey to you today is that memory is at the heart of AI. You heard earlier that in a memory system, if you think about the application processor as the brain, you can think about the memory as the heart. So speaking of the heart, I have seen this video several times, and it always gives me goosebumps, especially when Steve talks about in all that data is the cure for ALS or Parkinson's. So this is what really excites me about the power of AI, is this idea of precision healthcare. So I want to tell you a personal story so that you can understand why I'm excited about precision healthcare, why I've become passionate about it, and how as a technologist I can see how memory matters in the development of personalized medicine. This is my son, Connor. I took this photo in 2014 as he was getting ready for a school dance. In 2013, Connor was diagnosed with brain cancer. His is a solid tumor in his cerebellum called medulloblastoma. There are only around 350 cases of medulloblastoma diagnosed each year in the United States. So after surgery to remove the brain tumor, Connor started treatment, and I remember the day because it was the day after his 16th birthday. And we had a couple of treatment options at the time, but they both involved a 20-year-old protocol of radiation and chemotherapy. The second option was to move across country, take him away from his friends, and add stem cell recovery. But when his oncologist told me that the predicted outcome was the same, we opted to stay home with our support network. Connor's treatment took an entire year and is probably another year for him to recover. And right now, I think I've worried you, so I want to just reassure you that Connor is fine. He's studying kinesiology at university, and he has a bright future. In this photo, he was exhausted, but he still managed to stay out till midnight that night. So why am I telling you this story? When Connor got sick, I started reading. I'm trained as a scientist, so when there's a crisis, I do research. And I started reading about medulloblastoma, and I started learning about this thing out there called targeted gene therapy and the promise of precision healthcare. I learned that doctors no longer think of medulloblastoma as a single disease, but it's a tumor with 4 distinct molecular pathways. Connor's particular mutagenic pathway was called sonic hedgehog. So I didn't stop reading. I'm still reading about this, and more recently I read that there's been a breakthrough, and doctors are now seeing that one subtype of Connor's cancer is responding to targeted gene therapy. So my feeling about the power of AI is that these breakthroughs will accelerate now, and that we won't wait 5, 10, 20 years to get a new protocol. Because doctors are starting to tailor treatment plans based on DNA sequencing, and researchers are starting to classify tumors based on DNA sequencing. These are some data that reference what can happen with DNA sequencing in the case of the treatment of childhood cancer. In 95% of the time, the information from DNA sequencing will yield to the future discovery of new drugs. 46% of the time, something actionable will be found that can help the patient's care, and then 25% of the time, we'll actually be able, from DNA sequencing, to tailor the treatment plan. The hope is, in the future, that cancer will be treated with far less invasive treatments and far better statistical outcomes. This vision for precision healthcare depends on the collection of vast amounts of data. There will be clinical and molecular and pathological data collected over a patient's lifetime. Connor will be in that data set. So what I'm saying is this is a big data problem, and this big data problem needs a memory-centric solution. So new memory technology will contribute to this acceleration of learning that I've been talking about. Memory will help get to the answer faster. These huge genetic databases are going to need higher performance working memory and higher capacity storage memory. Memory technology will contribute to faster and more accurate diagnosis and treatment, and this will lead to lower costs and improved outcomes. So, as a parent, when you're faced with this situation, you want nothing more than to get to the answers faster. What's exciting to me as a technologist is we can use memory technology and the power of AI to solve these important technical health challenges. This is what inspires me as a technologist and makes me proud of what we're doing at Micron. So let's talk about that. Let's talk now about what Micron's doing. We're working with leading researchers to understand how our memory and our hardware can be optimized for AI and machine learning. So I'm going to tell you about a couple examples of work we're doing with key collaborators using an FPGA accelerator card that we've customized with our high-performance, high-density memory. I'll start with some work that's being carried out at the Knight Cancer Institute at the Oregon Health and Science University. The goal is to take high-resolution images acquired from electron microscopy and use machine learning to create 3D images of cancer cells. To do this, we use the power of an accelerated machine learning inference engine combined with Micron's fast memory to analyze these images quickly and accurately. The standard processing of these images oftentimes requires that they be sliced into many pieces, sometimes thousands of pieces, and then restitched at the end of the process, which can cause some anomalies or artifacts and affect the accuracy. Sometimes it can take weeks or months to create one 3D image of a cancer cell. Our technology allows the processing of the entire image without slicing, without restitching. So this is important because researchers need to analyze many images from many patients to understand how the patients are responding to tailored treatment options. And our technology, accelerating the process and improving the accuracy, can help speed the research to find personalized cancer treatment options. This work, by the way, is being exhibited downstairs in the Experience Zone. So I invite you to visit the Oregon Health and Science University exhibit after the program. I'll give you another example of work we're doing along these lines. We're initiating a project with the Department of Energy and Lewis Rhodes Labs to use Micron's custom hardware to analyze an unstructured data set from a very large patient population. Consider the millions of veterans in the United States and all the files associated with their medical care. Doctor's notes, test results, imaging files. Often the answers are hidden in this data set, a data set too large to be interpreted without the power of AI. So perhaps from this work we can understand and diagnose and treat things like cardiovascular disease or traumatic brain injury better, or contribute to patient-specific analysis to understand suicide prevention. So in general, as humans, we can't see the patterns in this huge data set. And if we put a standard computer on it, it might solve the problem, but it'll be 50 years from now and a lifetime from now. With the power of AI, we can solve this solution set. We can find solutions within this huge data set within a matter of minutes. So I want to emphasize that in both of these cases and others, we're working with key collaborators to understand how our memory can be better optimized for AI and machine learning and to develop and test novel architectures. Now I'm going to switch gears and talk about give you a few examples of Micron's memory technology. I don't have enough time to go through the entire portfolio, so 3 examples. And to do that, I want to introduce a persistent challenge in the memory industry. So the challenge is to continue down this path we've been on of exponentially improving performance, bandwidth, and speed while simultaneously reducing cost and power consumption. I want to focus on bandwidth, and I know some of you know what that is, but maybe some of you don't. So I'll tell you that in a modern system, the system performance is inhibited by the narrow bus that connects the application processor to the memory because the memory can't supply data at the rate that the application processor can consume it. So that was a lot. That was a mouthful. So let me give you an analogy to explain bandwidth further, and I'll come back to this analogy a couple of times. This may look like your daily commute in the Bay Area. Everyone's trying to go somewhere on the same freeway at the same time, but there are too many cars and not enough lanes. This is what it is to be bandwidth constrained. Just like us, data has to commute to work, and the commute can be unproductive, a waste of time and energy. But if we expand the number of lanes, we can accommodate more cars. So if we can find ways to improve the bandwidth in a memory system, this will allow more data to flow faster. Once we know we need better integration of compute and memory to improve the speed and transfer of data. One solution is high bandwidth memory. High bandwidth memory uses an innovation in packaging to enhance performance and speed, and also memory density in a smaller footprint. So what if you can move your home closer to the office in the commute analogy? With high bandwidth memory, we bring the memory closer to the application processor and realize enhanced performance and speed. I want to shout out to the creative department for these amazing animations. I think they're really cool. But here we're using our mature TSV technology to stack DRAM vertically, in this case 8 high. TSVs are through silicon vias, which are tiny electrical vertical connections that pass completely through the silicon wafer or die. This memory is a unique way to package our high-speed DRAM and is nicely positioned to enable demanding graphics and networking applications. Now I'm going to move on to talk about our innovations in NAND flash. We have AI-ready flash storage, and we can make it smarter. NAND flash is sometimes left out of the discussion because of its relatively low performance, but in fact it has the highest memory capacity of any memory, and so it can store a lot of data, which is important for AI applications. So as you saw in the video, Micron has the CMOS under array technology, which is a way to put the peripheral circuitry under the memory array. It minimizes die size and lowers manufacturing costs. All the intelligence to interact with the memory bits is now under the array. So this is like if you can skip the daily commute and have a home office in your basement where work can get done at a low cost. The other advantage, as you heard in the video, is that it allows us this opportunity to enhance the performance, provide further optimization of the memory. We're also making NAND flash bigger or more dense. Micron is the first to bring to market quad-level cell, or QLC technology. QLC can store 4 bits per cell, 33% more than triple-level cell NAND. QLC is fast, high-capacity storage. This is really important for read-intensive applications common with AI workloads. QLC delivers speed for these immense data sets we've been talking about because machines can only learn as fast as they can access and analyze data. QLC delivers speed at low cost, which we think is really important because this will help us bring data closer to where it's being analyzed. So I wanted to just talk about 3 examples of how we have innovations to make our memory faster, smarter, and bigger, and point out that in all 3 of these cases, they address the persistent challenge that I talked about earlier, and that we'll continue to innovate down this path. So, as I said at the beginning, memory is at the heart of AI. And I really want to leave you with 3 important messages. Number 1, if AI and machine learning are about getting to the answers faster, then this can't be done without memory. The answers are in the data, and data lives and moves through memory technology. Number 2, At Micron, we're working with the brightest minds in the industry to uncover new uses for our memory in AI and machine learning. Now more so than ever before, memory matters. Number 3, we are AI ready. Our memories are AI ready. As Sanjay said at the beginning, we are transforming how the world uses information to enrich life. So I realize Connor's story is not unique. Everyone has a story, and everyone can think about how these amazing developments we've been talking about today will enrich our lives in life and in healthcare and in business. So to realize this future, we need the youth of today to be inspired and energized about AI, and we need them to be excited about science and technology and engineering and math. That's why I'm excited today to have the opportunity to announce Micron's next recipient of Micron Foundation's Advancing Curiosity Grant. This grant will go to AI for All. AI for All is an organization dedicated to creating a pipeline of future talent in AI. And we have here today Tess Posner, who's the CEO of AI for All.
Thank you so much. We're so excited about this. Thank you for this amazing award and support. How many of you in this room, after this amazing day, are excited about AI? Raise your hand. Absolutely so exciting. To quote you from before, AI has the potential to really address some of what we used to consider maybe unsolvable challenges in the world today. But as you said, to actually live up to this exciting potential that we all have so much energy about and that you've heard amazing things about today, we have to have the right talent building it. And we have to have the right diverse talent that actually represents our complex and diverse society. So that's exactly why we started AI for All. AI for All is a nonprofit organization that's working to create the next generation of diverse AI leaders. And we run AI education programs focused on underrepresented talent. In partnership with UC Berkeley and Stanford, some of the other recipients, which is really exciting, and Carnegie Mellon University and Princeton University and other great organizations that are helping us really shape the next generation of leaders. But we don't just help our students build technical skills, we also help them understand and get excited about all of the amazing opportunities that AI has to offer, how it can potentially cure cancer, and really enhance our abilities as humans to solve some of the biggest challenges facing the world today. Our students, who are mostly in high school, are already going on to do amazing things. They're winning awards for their AI research. They're solving problems in their communities using AI technology. And they're teaching others, starting AI clubs at their schools and AI hackathons. So imagine what they'll do in the future. And we're so excited about this award, and it's going to allow us to expand our AI summer camps to reach more future AI leaders, future diverse AI leaders, and really be able to unlock AI's potential to solve big challenges in the world today. So thank you. We're so excited about this partnership, and we look forward to working together.
Thank you, Tess.
Thank you.
Innovators like Tess are paving the way to the future, working to educate the next generation of technologists, thinkers, and leaders. So we feel like that's really important, educating thinkers in AI. And we know that memory has a central role to play in the AI revolution. And we believe that Micron is AI ready. Thank you. So please join me in welcoming David Kirkpatrick back to the stage.
Okay. Well, so now we're going to dive into a specific industry, automotive, one that we all know and love generally. And we've got, again, two incredibly knowledgeable experts on stage, so kudos again to Micron for that. Next to me is Simon Uringer, who runs all of BMW's research in the United States, and a lot of it involves AI. BMW is a company that has been pretty ahead of the curve in terms of automation in the vehicle, so we'll hear a lot about that. And then Vijay Nadkarni, who is with Visteon, and he is Vice President for AI, so he is the guy at Visteon who thinks about AI, Visteon being one of the largest, as they call them, Tier 1 auto parts? Is that
suppliers.
Suppliers. I don't know. Parts is actually not even a word that works anymore. But Visteon is huge, and their products go in how many different manufacturers?
Oh, we have about 25 OEMs around the world that we supply
25 car makers around the world use Visteon stuff. So, well, why don't we start with you, Vijay? When you're the vice president for AI. So what does that mean for a supplier of components to cars and vehicles?
So what we basically do is there are two main things in the industry that automakers are after. One is autonomous driving, which is a big thing happening. And the second actually is infotainment. The use cases for the two are very different. In autonomous driving, we essentially offer the automakers the ability to build cars, and we supply them essentially the mechanism by which the cars will be able to navigate by themselves. We do it at different levels. In infotainment, the idea is to basically give the driver a better experience in the car, and that experience can be by way of learning the driver's profile and making recommendations, or it could be maybe something a little simpler, as in improving the driver's productivity. But essentially, that is what we offer the OEMs so that they can offer that to the customers and give the customers a reason to buy more cars or get a better experience in their cars.
I mean, when you're talking to these multiple car makers around the world in all the major countries, do they see AI as a competitive differentiator, do you think, as they compete with other automakers?
Yes, I think so, because AI essentially brings a new dimension to the way the automakers or the OEMs have been building cars in the past. It really allows, first of all, it allows an entirely new set of features, but it also makes existing features a whole lot better. For example, many cars have adaptive cruise control that is not AI, but when you have AI-based adaptive cruise control, it is a clear step ahead. So both in terms of the existing features and the new things, we offer essentially something compelling to the automakers.
Okay, so, I mean, we sometimes hear it said, I think, that cars are becoming computers on wheels. Does that seem to be excessive, or is that a reasonable way to think about where we're headed?
Well, certainly the cars are becoming computers on wheels. They have been computers on wheels for a while, actually, although the computers are getting more and more sophisticated now with AI and actually even with other technologies. But essentially, these computers have to be trained to do the AI capabilities efficiently and well. AI can also, if it's not trained properly, it can create a lot of mischief as well. And so we have to be very careful with how we introduce AI, and we don't want to introduce it prematurely. So we have to really make sure that whatever AI we put in the vehicle is tested thoroughly, and that it goes through a certain, I would say, period of baking or refinement before it really makes its way to the end user.
Yeah, if they make a mistake with Alexa, it's not as serious as if you guys make a mistake.
But a mistake with an autonomous car can kill people. It's a perfect killing machine.
We don't want that. So Simon, talk about BMW's thinking on AI as a phenomenon.
Well, as a phenomenon, we have it incorporated already in the vehicle with voice assistants, of which we have already also announced our own now, but having integrated all of the usual voice assistants that you might have. So that is typically something where you would expect a car maker to do an integrative part, and so that is already there.
So Alexa, Siri,
Google Assistant,
they're all integrated
in
into your
the car and available since a couple of times. either inside out from within the car to the outside, or outside in from your home to check whether the car is locked. And also there is the own assistant. So that has arrived in the infotainment portion that you mentioned. Now, obviously, also in the AV portion, in the autonomous driving portion, AI is a big part of it. But not everything is AI-based, obviously. So there is a behavioral portion in all of the things that a car will do to take you from one place to another, or a car that takes up time to find a parking space, right? There's a behavioral portion that you would expect to be as smart as possible and as convenient to whatever your style is as possible. And then there is a non-behavioral part of the vehicle that you would like to never change, like the shape, the smell, the look of the car, right? That you would expect the vehicle to stay like it is. And so AI is there, but AI is not everything. So it's like the integration and how intelligently can it come together. That's really what drives us, and in terms of engineering question, keeps us busy.
Well, one of the things you mentioned is the style that each of us have, our own very, idiosyncratic preferences.
Yes.
And that probably is something you have to factor in both for the autonomy features of the driving of the vehicle as well as the infotainment, right? So is that where a lot of the AI is going to come in, is adapting to what an individual actually wants?
Exactly, because look at the behavioral aspect of driving, right? We are probably not all driving the same way, right? Defensive, aggressive, and also not within our daily day, right? We're potentially driving differently depending on our mood.
Yeah.
This is what exactly you would expect from a vehicle that drives you, right? So the behavioral portion has to be AI-based in order to be convenient, because you wouldn't expect, let's say, a BMW drive style in all of the situations that you will be driven, right? Because you might not be in the mood for that particular sporty or whatever fuel-efficient drive style, because your behavior is changed, your preferences will change, and so all the behavioral portions of anything we solve computationally is to be AI-based and to be adaptive to mood, to situations, to context.
Yeah, well, situations. So, Vijay, mood is one thing, but different trips are for different purposes and will be done in different ways. And does AI enter into that too?
Oh, absolutely, because AI does one thing that's very important, which is it allows the car to learn and adapt to different drivers and their personalities, their behavioral profile, and so on. And very often, for example, let's take infotainment, because that's there are better use cases for that. But the car can actually learn about a person's habits in the car, and also the points of stoppage of the car. And from that, the car can essentially learn what the driver likes to do at different times of the day, in different weather conditions, as to when they fill gas, what restaurants they like to go to. All of these become individual nuggets of the driver's behavior. And these individual nuggets are then essentially sent to the AI learning engine. And the AI learning engine can then have the repository. And following that, and of course, it'll keep learning on an ongoing basis. But then as the car makes more and more trips, it'll find itself in situations or scenarios where the driver could benefit from a recommendation, for instance. And the recommendation can be tied directly to the profile that a car has learned about that driver. For example, I give you one simple use case. Let's take something as simple as just filling up gas. Okay, the car can learn that the fuel is running low. You don't need AI for that. It just knows that directly from the CAN bus. But the car could learn whether the driver likes to refuel at the start of a trip, at the end of a trip, what brand gas station the driver likes. Some drivers like to refuel when the gas tank is exactly at, say, 10% or 5%. All of these are things that a car can learn about a driver, and then the recommendation that it makes to the driver about a gas station will match those recommendations, not just that the gas tank is running low.
Now, is that kind of inference and calculation a specific functional part of the car? In other words, there's a lot of different parts of the car where AI is playing a role, right?
Sure.
Is there going to be sort of a personalization engine which is part of every vehicle, in effect?
Well, it'll differ for the type of system that you're talking about. What we would use for autonomous driving will typically not be the one that we will use for infotainment.
Right.
And the two, in fact, will, at least for now.
So there could be two personalization.
Right. There'll be what we call ECUs, but they're basically computing engines that will essentially serve the purpose of what a car wants to do with that thing. So for infotainment, what we would typically have is a personalization engine that is really dedicated for infotainment, and for autonomous driving, we would have a personalization engine that is dedicated for autonomous driving.
Right. So I want to get into autonomous driving, self-driving in some detail in a minute. But Simon, how many different kinds of AI would you say there will be, or there are in let's say are and will be in a specific car?
Well, in the car, I think we can agree that the infotainment portion and the AV portion is one of them. Obviously, also all chassis-based control functions can benefit, right, from taking AI-based learning approach. I think where we see more and more is the outside-in portion. So every app or every system that you use that connects with the car, whether it's in a fleet management, for example, when you want the car to pull up to you, or any use cases where you are not part of the driving vehicle, right? A use case where a car parks itself, right? So this is going to be one typical example. You drop off the car here at the venue, and the car will park itself. That is going to happen, and that has to be that can be solved very elegantly or not very elegantly. And I think this is one of the portions where we see AI as the major driver. This is not a rule-based thing,
so to speak, right? So in other words, I mean, could there be AI in the braking system, AI in the pollution management system, AI in the vision system? I mean, or is that ultimately going to be one networked AI in the vehicle, or is that not the right question?
Well, there is a number of use cases in a vehicle that will not benefit from AI. Purely deterministic pieces of software that are just like state machines that happen to be part of the systems that we interact with. And also in a driving policy, when there are obvious situations on the road, you're about to hit an object within the next second, there is a lot of AI you need.
You don't need, that's what you mean by deterministic. If there's an object in the road, stop. That's an if then.
That's pretty simple. So there are situations where it's pretty evident that AI will not help the situation.
Right.
But there are a ton of situations and ton of use cases in the vehicle where AI, again, any behavioral aspect like in-cabin control, especially when the driver is freed up of the task of actually piloting the vehicle, then we want maximum driver distraction or sleep or entertainment or productivity, and that is obviously where AI can help a lot.
Okay, before we get to the autonomy, I know one of the things you've thought a lot about is this issue of productivity. Mm-hmm. So talk about what Visteon's thinking about that and what it may be like riding in a car in the relatively near future.
Sure. So productivity is very simple. When I commute to work or back home, of course I'm listening to music or the news or something like that. But in my head, I would be rather maybe getting some work done during that time. So basically, the concept is that we can do a few things that we would normally do at our desk, but now we can try to bring them into the car. A simple case is making phone calls, taking an appointment. We all have calendars, and they typically have invites that with phone numbers. So using AI, what we can do is essentially read the person's invite. Now, that is already being done, but where AI comes in is it can determine whether a particular invite has a phone number. We need to be able to distinguish the phone number to call from, say, a phone number that might be in the signature block of that invite. So that is one thing that AI can essentially do. It can distinguish between say, a phone number from a conference bridge. In certain cases, the conference bridge may have a leader pin. So AI can essentially separate out all of these. In certain cases, the invite may not even have a phone number, but it may be a situation where there is no phone number, but it is with a person. And if the car is moving at a certain point, then the AI system can infer that the appointment is at a remote location. And if the person is running late for the appointment, it can determine that by itself and then allow the person to make a look-ahead call or an advance call to the destination party. All of these are things which are basically possible, and all of these basically improve the productivity in the car. And that's with invites. The other aspect of this is simply text messages or emails. Very often, you all get text messages, and some of us sneak a peek. And more than that, we even respond, which we should not be doing. But in this, what can be done is the AI can intercept incoming text messages and display them in the head-up display. Or the same thing with emails. It can essentially intercept emails and then essentially on the head-up display or on the cluster, show the sender name, the caption of the email, the subject, and then maybe the first line or first two lines, things like that.
So one thing that confuses me when I hear examples like that is what will be done by the car and what will be done by other systems. I mean, for example, the phone itself might be able to detect that you're in the car and do an awful lot of what you said. And of course, Apple has CarPlay and can automatically integrate with the car already. So how do you figure when you're thinking about planning future cars, whether it's going to be the phone and the systems that come from a company like Google or Apple or Amazon that will be doing this work, or will it be the systems that are developed by the car maker? Is that get fuzzy and is that uncertain?
So what we are seeing is something quite interesting, which is that in the OEM world, not everybody is going after Google, or in certain cases, I think what we're seeing is that there are OEMs who definitely want to go the route of Google. And in some cases, there are OEMs who may not necessarily want to go with Google or with Apple. And the reason is they essentially want to maybe at least keep some level of engagement or I would say the account control of the user to themselves. And because of this, the level of functionality that you see in CarPlay is limited. For example, I don't know how many of you know, but CarPlay doesn't let you download any app you want. You can only download it only comes with about 10 to 12 apps right now. And you can, let's say you want to download Evernote. Okay, it's a very popular app on the mobile phone, but in a car, you cannot get it. Okay, so there are things like this which are imposed by the OEMs. And for companies that essentially are maybe less anxious to get after Google, this could be an alternative.
Okay, of course, what Apple and Google and Amazon decide they want to do with their devices will evolve over time. And you obviously have kind of at BMW made your bet. If you told us just now that you've got your own voice assistant, right?
Yes.
So you're basically going head to head with Google and Apple in a certain sense. Is that a fair statement?
We are augmenting in a field where those assistants wouldn't go. So we are not shielding anything. Essentially, we have had Alexa in the car way before we had our own assistant. So we are totally aware that for many of the infotainment aspects, we will not be the OEM of those functions, right? So a voice assistant that does so many things in your life will never come from a car brand. That's
so why do you need a voice assistant then?
Because our voice assistant can augment in all of those things, in all of those situations where you have the contextual benefits of the situation you're in, right? And so basically any basic interaction with the vehicle, right? Like warmer, colder, any type of everything you can do with a control today can be done over voice. That's not what is in the main focus of an Alexa. And that's what an Alexa cannot do today, also because of all the proprietary systems. So, also, questions like, okay, where is the washer wiper fluid, whatever. Any type of question or interaction that you would have with the vehicle will be augmented by the own assistant. And it will also seamlessly hand over to other assistants if you like so.
So if you're in the driver's seat and you're in a car of the type you just described, so you'll say Alexa so and so, or you say BMW so and so. How are you distinguish? I mean, you press a button. How would you distinguish between which voice system you will be using, and will there be more than two, even possibly?
There are more than two already now.
But that an individual would be using more than two at the same time, potentially?
Potentially, yes.
Okay, that sounds confusing.
Well, it's up to everybody to decide which number of assistants you might be using, 0 to as many as are out there. Some prefer to use one. As a car maker, I think it is about integration, and it's about not pretending to be the solution for something which is clearly not the OEM's home turf. And so, yes, there will be a coexistence, and yes, there is a seamless handover, or no, there is no trigger word for the BMW assistant because you can choose your own trigger word.
Okay, but you'd have a separate trigger word for that than you would for Alexa or...
Well, basically, if you don't use any trigger word, then the own assistants will try to answer that question. But if you ask what's the highest mountain in the Bay Area, then it will probably hand over to Alexa, which is your preferred assistant.
I got it. Okay. So, we've talked about autonomy. It's come up a few times. And so self-driving, we assume, when we hear about self-driving cars, it's generally talked about as if AI is the way we will do that. But interestingly, both of you explained that that's not really the right way to think of it. Could you start, and then Simon, you...
Yeah, so AI first of all, won't solve every problem that the world has to offer, and we don't even try to. Typically, AI will have to be combined with something that is rule-based or heuristics-based or whatever it is. And it has to be done in a manner where you don't sort of put an excessive dependence on AI, because AI also, I would say, needs to mature a little bit further in certain areas. And while that maturation is happening, what will happen is that you have a combination of some AI and maybe some rule-based. And then as time progresses and as the technology evolves, you'll find that it'll be more and more AI. I don't think, at least in the foreseeable future, it'll come to a point where it is purely AI for anything at all. So it's basically going to be a blend. But I would say, getting to autonomous driving, I mean, there are basically, I would say, two big areas of autonomous driving as to where AI would be used for autonomous. One is in what we call object detection, which is detecting pedestrians, vehicles, traffic signs, lanes, that sort of thing. The other area is essentially what we call path planning, or we actually like to call it vehicular maneuvers, where the vehicle actually executes specific maneuvers, such as a simple one is lane keeping, but other ones could be maybe making a lane change, making a turn at an intersection, things of that sort. And for the first one, we basically use an AI technology called convolutional neural networks, CNNs. And CNNs today are it's basically, I would say, one of the more mature, I would say, technologies in AI today. The other one, which is path planning, uses a technology called reinforcement learning, which is, I would say, a little earlier in its infancy. And that has a lot of potential, but it also has, I would say, a certain amount of maturation that's still required before it goes whole hog into a car. A lot of the cars you see today, whoever they might be, BMW, Tesla, whatever it is, most of them do use CNNs in one form or the other. Not that many today use reinforcement learning, but they will over time, and that's part of the whole maturation that will happen.
Okay, so Simon, how do you think about autonomy as a ecosystem? In other words, how much self-driving are you attempting to achieve in your vehicles right now?
Well, today we are at level 2.5, so to speak, right, is what is on sale today, and it's independent of car brand, roughly. We're targeting a solid level 3 in July 2021. With
level 3 meaning the car could take over a larger percentage of the function.
Yes, and a level 4, a mind off. So basically defined, a level 4 defined as mind off, right, and level 5 as driver off, right? So mind off capability in level 4 will be available in 2021.
I mean, you have to sit there holding the steering wheel, but you don't have to do anything.
No, you
unless
don't have to. No, mind off is even after eyes and hands off. So mind off means you can sit in the car, have your mind not associated with anything that has to do with driving. That will be available in July 2021 with the BMW brand.
But not for everything you do, obviously.
No, for some road segments, especially a highway setting. That will
from the on-ramp to the off-ramp kind of thing.
Kind of. And so that is going to happen, definitely, and that is going to incorporate a lot of AI portions in the behavioral part. And we believe that reinforcement learning approach, and that is especially something that we do here in the Bay Area, we believe that with a reinforcement learning-based approach, we can meet the expectations of the way that we are being driven is convenient. And I think that is an upside to any RL-based behavioral model rather than any deterministic or rule-based algorithms that are also under development right now.
Okay, so obviously companies like Google and Uber and Baidu are trying to get fully self-driving level 5 cars. But you said something very interesting, and unfortunately we're really pretty much out of time, but you said something very interesting about how cars are pretty much all world cars now. Basically, the cars you build to be used anywhere in the world, right? But unfortunately, the regulatory landscape is extremely fragmented. So your point was what in saying that?
Well, often there is a question, when will it be there? And the answer is, it depends on how consistent the regulatory environment is throughout the world. We will not be able to have a different path planning a component in the vehicle for a car in Pittsburgh than for a car in here, or even for a car in Europe and in the US. So at the moment, we are living in an era where we are seeing regulatory environment and legislation coming up, and we will need the most consistent, regulatory environments in order to speed up the delivery. We cannot afford so many variants, being localized.
Do you see that consistency on the horizon, or is it still pretty far off?
I'm still optimistic.
Okay. Does that sound right to you?
I think so, yeah. I think essentially there'll be more and more of the AI coming into the picture as we go along, and a lot of it is already there today, but it is to some extent bottlenecked by regulatory issues, and to some extent it is also bottlenecked by, there's always the 0.01% use case, and that 0.01%, unfortunately, if it can lead to accidents, will essentially be a barrier to adoption.
Right. There's got to be pretty much absolute reliability.
Correct.
Right. Well, thank you both so much. I wish we could have more time to continue, but it's a great conversation.
Thank you.
Thanks, Simon.
Thank you.
Thanks, Vijay.
Thank you.
Okay, now I get to introduce our next speaker, who is the keynote, and I'm very eager to hear him myself, Max Tegmark, who is Swedish, but he teaches at MIT. He's a physics and AI researcher, and he's a professor of physics there. But listen to some of the things he does. He's president of the Future of Life Institute. He's scientific director of the Foundational Questions Institute. He works at the interface between physics, AI, and neuroscience. And then I'm just going to read you the title of two of his books so you get a sense of what a big thinker this guy is. Life 3.0, Being Human in the Age of Artificial Intelligence is one book. And the other book, which is even more interesting title, Our Mathematical Universe, My Quest for the Ultimate Nature of Reality. So, Max Tegmark.
It's such an honor and pleasure to be here today. I feel extra happy when I'm here looking out the Bay Bridge, because when I first came from Sweden to the US, I came to right over there for grad school. So I think the book that got me invited here was this one about AI, and I'm honored that you felt that I was a big thinker, because I have come here because I want you to think big. Really big. Even though my technical research at MIT these days is on AI, my background is in physics, so when I say really big, I mean like cosmic big. So let's begin on this scale. After 13.8 billion years of cosmic history, our universe has woken up and become aware of itself. From a small blue planet, like tiny conscious parts of our universe, it began gazing out into the cosmos with telescopes, discovering something humbling. We've discovered that our universe is vastly grander than our ancestors imagined, and that life itself appears to be an almost imperceptibly small perturbation, on a seemingly lifeless, dead universe. But we've also discovered something inspiring, which is that the technology that we're developing has the potential to help life flourish like never before. Not just for centuries, but for billions of years. And not just on Earth, but throughout much of this amazing universe. I think of the very earliest life as 1.0, because it was really dumb, like bacteria, unable to learn anything during its lifetime. I think of us humans as life 2.0 because we can learn, which we in nerdy geek speak might think of installing new software into our brains, like languages and job skills. Life 3.0, which can design not only its software but also its hardware, of course doesn't exist yet. But perhaps our technology has already made us life 2.1, with artificial knees, pacemakers, and cochlear implants. So let's take a closer look, all right, at our relationship with technology. Raise your hand if you saw the Apollo 11 launch live. Oh, I'm so jealous. I was only 2 years old. This moon mission was both successful and inspiring because it showed that when we humans use technology wisely, we can accomplish things that our ancestors could only dream of. But there's an even more inspiring journey, propelled by something more powerful than rocket engines, where the passengers aren't just 3 astronauts, but all of humanity. So let's talk about our collective journey into the future with artificial intelligence. My friend Jan Tallinn likes to point out that just as with rocketry, it's not enough to make our technology powerful. To be truly ambitious, which I think is a theme of today, we also have to figure out how to steer it and where we want to go with it. So let's talk about all three now for artificial intelligence: the power, the steering, and the destination, beginning with the power. So intelligence, artificial intelligence. What is intelligence anyway? I define it very inclusively as simply the ability to accomplish goals. The more complex, the more intelligent. And I give this very inclusive definition because I want to include both biological and artificial intelligence. So artificial intelligence I'm defining as simply non-biological intelligence. And I want to be this inclusive because I want to avoid this silly carbon chauvinism idea that you can only be smart if you're made of meat. I think the key to the success that we've heard about today in AI is exactly the opposite of carbon chauvinism. It's this idea that intelligence is all about information processing. And it doesn't matter whether the information is processed by carbon atoms in cells in brains, or by silicon atoms in Micron-produced devices, or in some other atoms in future technology. It's the information processing itself that matters. And I have many colleagues who think that we'll never get really advanced human-like AI because they think intelligence is something mysterious that can only exist in biological organisms like us. That, again, is carbon chauvinism that I want to encourage you to just let go of. This powerful idea that it's all about information processing has led to dramatic progress, as we've heard, both in hardware and in software propelling intelligence. On the hardware side, nobody knows better than you folks at Micron how amazingly memory has gotten about 100 million times cheaper in the last 60 years. And computing itself has gotten 1 million times cheaper. I sometimes wish that would happen when I went shopping to the prices, because if it did, I could buy all of the world's products and services produced during this entire year for 1/100 of a cent. And we've heard a lot today about fantastic progress also on the software side, specifically to do with machine learning, neural network-powered ideas. And this is all driving artificial intelligence towards new heights. Think about the recent progress. Not long ago, robots couldn't walk. Now they can do backflips. Not long ago, we didn't have the self-driving cars we were just hearing about on the panel. And now we have self-flying rockets. Not long ago, AI could not do face recognition. Now AI can generate fake faces, and it can simulate your face saying stuff that you never said. So watch out. Not long ago, AI was just a research area. Now it can save lives. We've already heard here about how AI can save many of the 40,000 deaths on US highways and many of the 1.2 million lives wasted every year on Earth on the roads, and probably a lot more lives can be saved in healthcare applications by avoiding preventable mistakes. And that's just the beginning, avoiding mistakes. Clearly, if we can use AI to also do better medical science, there is just so much more we can do. Better diagnosis, treatment planning, personalized medicine, as we've heard about, developing new medicines, new medical devices. In terms of what we already have AI diagnosis matching human expert performance on prostate cancer, on lung cancer, on eye diseases, as we heard about. And another thing to think about is that not long ago, AI could not beat us at the board game of Go, often viewed as the most daunting strategy game of all. Then Google DeepMind's AlphaZero AI took 3,000 years of human Go games and Go wisdom, put it all in the trash, and learned to become the world's best Go player just by playing against itself for 24 hours. And the most impressive feat here was not that AlphaZero crushed human gamers, but that it crushed human AI researchers who had spent decades handcrafting Go-playing software. And AlphaZero also crushed AI researchers in chess, playing 100 games against Stockfish. Those of you who've played against Stockfish know what it feels like to lose in chess. It played 100 games, didn't lose a single one, even won a bunch of against black. Been working on this handcrafting chess-playing algorithms since 1950, all blown away. So all this exciting recent progress really begs the question, which I think the organizers wanted me to come here and ask. We're accelerating intelligence. Listening to all the speakers earlier today, I could really just palpably feel the acceleration. But what are we accelerating toward? Where is this all going to go? First of all, how far is AI itself going to go? On the hardware side, I think it's clear it's going to go very far. We heard about continued optimism despite all the talk about Moore's Law ending. I couldn't agree more. Today's smartphones and computers generally compute by shuffling electrons around in 2 dimensions. Well, we heard from Linda how we can do a lot better by starting to go into 3 dimensions. She here just before me. There's so many other things you can do if you're only limited by the laws of physics. There's fantastic startup technology happening, moving photons instead of electrons, promising speed-ups of a factor of 1 million or more at the same power consumption for machine learning applications. And in fact, the ultimate limit there is really only going to be, maybe 1 bit per atom, which we're so far away from. Even what we heard earlier today from Sumit about DNA. DNA uses only about 100 atoms per bit, which is just so much better than what we do in our devices today. And for computing, there's this nice paper by Seth Lloyd showing that the fundamental laws of physics put a limit on how much computation you can do with a kilogram of matter. That's 34 orders of magnitude above where we are today. So don't worry about Moore's Law. There's so much room to go. And what about the implications of better hardware and better software for what we can actually do with AI? How far will AI itself go in its capabilities? I think about this question in terms of this abstract landscape of tasks, right? Where the elevation represents how hard it is for AI to do each task at human level. And the sea level represents where AI is today. The sea level is obviously rising as AI improves, so there's a kind of global warming going on here in this task landscape. I think it's okay to talk about global warming here since I'm in California now. So one obvious takeaway from this is that we should avoid careers at the waterfront, which will soon be disrupted by automation. But there's a much bigger question too, isn't there? How far will the water end up rising? Will it eventually submerge all land with AI matching human intelligence at all tasks? This is the definition of artificial general intelligence, AGI, in contrast to artificial narrow intelligence, which is everything we've heard about so far here at this fascinating event here today. And by this definition of artificial general intelligence, people who say, there'll always be jobs that humans can do better than machines, are simply saying that we're never going to get artificial general intelligence. Now, if you think that AGI sounds kind of like crazy science fiction, you need to be clear on the fact that there is something else which sounds like even more crazy science fiction, namely superintelligence. So what's that? Well, if we actually do get artificial general intelligence, then by definition, AI can do all jobs better than humans, including all the tech jobs that people here in this room are doing, including AI design, which means that we can replace all our AI designers by machines and develop much better AGI on a timescale which is no longer limited by the human research and development timescale of years, but perhaps much faster, which raises this very controversial possibility of recursively self-improving AI that rapidly leaves human intelligence far, far behind, producing superintelligence. Now, we need to stop now for a reality check. Is superintelligence just some crazy sci-fi thing which is only discussed by philosophers? I hear this a lot. So I'm going to let you decide for yourselves by taking a listen here to what some people say here on this panel that I moderated at a workshop in California last year, where many of them are absolutely not just philosophers, as you'll see. So let's hear what they have to say. So before I asked if superintelligence is possible at all according to the laws of physics, now I'm asking, will it actually happen? Yes, no, or it's complicated?
A little bit complicated, but yes.
Yes, and if it doesn't, something terrible has happened to prevent it. Yes.
Probably. Yes. Yes.
Yes.
Yes.
No.
So, well, aside from Elon joking there, all the other yeses, the third yes, for example, Demis Hassabis, founder and leader of Google DeepMind, gave us AlphaZero, definitely not someone who has no clue about AI. Stuart Russell, AI professor just across the bay there where I did grad school. Bart Selman, AI professor, etc., etc. So we clearly can't dismiss this as just pure philosophy because some of the best AI researchers on the planet take it seriously. On the other hand, that does not mean it's going to happen, and in particular doesn't mean it's going to happen anytime soon. So we also have to ask this separate question. Well, how soon will we get artificial general intelligence, or maybe superintelligence? Here we have a very genuine scientific disagreement. We have some well-known AI researchers like Rodney Brooks who say, won't happen for hundreds of years. And then we have people like Demis Hassabis from Google DeepMind who are much more optimistic, think it's going to happen sooner and are working hard to try to make it happen. OpenAI, right here in San Francisco, is also trying to build AGI. Recent surveys have shown that most AI researchers actually share Demis Hassabis' optimism, guessing that we are going to get AGI within a matter of decades. So within the lifetime of many of us. I think you guys look quite healthy by and large. So, and this begs the question, well, if that happens, then what? What do we want the role of humans to be if machines can do everything better and cheaper than we can? The way I see it, we face a choice. One option is to be complacent. We can say, nah, let's just build machines that can do everything better than us and not worry about the consequences. After all, if we build machines that make all human beings obsolete, what could possibly go wrong? But I think that will be embarrassingly lame. I think we should be ambitious. I think this is very much the human spirit. So I say, let's be ambitious and envision a truly inspiring high-tech future and figure out how to steer toward it. This brings us to the second part of our rocket metaphor, the steering. We're making AI more powerful, but how can we steer towards a future where this helps humanity flourish rather than flounder? To help with this, I co-founded the Future of Life Institute, as you heard, a small nonprofit whose goal it is for the future of life to exist and be as inspiring as possible. And, I love technology. Technology is why 2018 is better than the Stone Age. And I'm really optimistic that we can create a truly inspiring high-tech future if we win the wisdom race, if we win the race between the growing power of technology and the growing wisdom with which we manage it. But this is a difficult challenge because we're going to need to change strategies to win this race. Why? Because our old strategy used to be learning from mistakes. First we invented fire, screwed up a bunch of times, then invented the fire extinguisher. First we invented the car, screwed up a bunch of times, and then we invented the seatbelt, the airbag, and all the nice features you heard about on the last panel, and laws saying you shouldn't drive too fast and stuff like this. And it kind of worked out. But technology, of course, relentlessly gets more and more powerful, and at some point it gets so powerful that one mistake is one mistake too many. We don't want to accidentally have a nuclear war with Russia later today and be like, oopsie, let's learn from this mistake and just be a little more careful next time. No. With nuclear weapons, future synthetic biology, and certainly with anything as remotely as powerful as artificial general intelligence, learning from mistakes is a lousy strategy. It's much better to be proactive rather than reactive, plan ahead, and get things right the first time, because that might be the only time we have. Now, you guys are nodding. You might think this sounds sort of obvious, but it is funny, because sometimes people tell me, shh, Max, don't talk like that. That's Luddite scaremongering. But it's not scaremongering. It's what we at MIT call safety engineering. Think about it. Before NASA launched the Apollo 11 mission, they systematically thought through everything that could go wrong when you put people on top of explosive fuel tanks and launched them to a place where no one could help them. And there was a lot that could go wrong. Was that scaremongering? No, that was precisely the safety engineering that ensured the success of the mission. And that's precisely the strategy I'm advocating that we take with very powerful technologies such as artificial general intelligence. So to help with this, we've organized conferences. The most recent one was down the road in Asilomar here outside of Monterey last year, where we brought together leading AI researchers and other thinkers to discuss how to grow this wisdom we need to keep AI beneficial. And this last conference produced this list of 23 AI principles, which have since been signed by over 1,000 AI researchers from around the world, and in fact, just the other month was officially endorsed by the legislature of the state of California even. And I want to just tell you about 3 of these principles to give you a flavor. One of them is that we should avoid an arms race and lethal autonomous weapons. And the idea here is very simple. Any science can be used for new ways of helping people or new ways of harming people, right? For example, biology and chemistry are much more likely to be used for new cures or new materials than for new ways of killing people. Why? Because researchers around the world successfully pushed and persuaded their politicians that there should be an international ban on biological and chemical weapons. And that's why today, if someone tells you that they work in biotech, you're going to pretty much take for granted that they're a force for good in the world and developing new medicines, not that they're developing a new bioweapon. And that's exactly the vision that AI researchers very much share as well. We want to make sure that this is a power that's used for good. Another principle from this, it was that we should make sure to avoid extreme income inequality as a result of AI. So the way I see it, if we can dramatically grow the world domestic product by having machines produce almost all the goods and services we need, and we still cannot figure out a way of dividing this vastly enlarged economic pie in such a way that everybody gets better off, then shame on us. Now, raise your hand if your computer has ever crashed. I knew there were a lot of forests in California. That's a lot of hands. Yes, so then you'll appreciate this Asilmar principle, that we should invest a lot in AI safety research. Because as we put AI in charge of ever more infrastructure and decisions, we really have to transform today's buggy and hackable computers into robust AI systems that we can really, really trust. This is obvious to anyone who's working on AI for self-driving cars, and it should be. We need to make it obvious to our politicians also who fund research, because otherwise all this awesome new technology that we're developing can malfunction and harm us or get hacked and be turned against us. And this AI safety research has to include also work on AI value alignment. Because the real threat from artificial general intelligence and superintelligence is not that it's going to turn evil like in silly Hollywood movies, but rather that it's going to turn competent, very competent, and go ahead and accomplish a bunch of goals that are just not aligned with our goals. Think about it. When we humans drove these guys, the West African black rhino, extinct, why did we do it? We didn't do it because we were a bunch of evil rhinoceros haters. No, we did it because we were more intelligent than they, and our goals were not aligned with them. Tough luck for them. So, since AGI is by definition more intelligent than humans, to make sure that we don't put our species in the position of those rhinos if we build AGI, we have to figure out how to make AI understand our goals, adopt our goals, and retain our goals. And finally, what goals should these be? This brings us to the third and final part of a rocket metaphor here, the destination. We're making AI more powerful, trying to figure out how to steer it, but where do we ultimately want to go with it? This is the elephant in the room that still to this day almost nobody talks about because we're so focused on all the important short-term problems. Jobs, weapons, business challenges. But what sort of society are we ultimately hoping to create if we succeed in building AGI, which has been the goal of AI research ever since its inception? So I told you I want to encourage you to think big, and even though my day job is on AI these days, once a physicist, always a physicist, so I can't help myself but unleash my inner physicist a little bit here and think really big for a moment, because we humans have really been the masters of thinking too small, if you think about it. Again and again and again, we underestimated, we can lower the music a little bit here, we underestimated the size of our reality, thinking that everything we knew about was everything that existed. A planet, a solar system, a bunch of stars, hundreds or thousands of light years away. You know, when my grandma was little, that was everything. That was the universe, just a bunch of stars. They didn't know still. She didn't know that there were other galaxies. Not because she was dumb, but because nobody on Earth knew that there were other galaxies until 1925. Our Milky Way galaxy, with hundreds of billions of stars, that we now know, of course, is just one among a vast number of others. In still bigger structures, groups, clusters, superclusters. We are looking here at this map, the biggest three-dimensional map of our universe to date that I had a lot of fun with working to make in the years with my colleagues on the Sloan Digital Sky Survey, which in turn is part of this even grander structure, our observable universe, or just our universe for short. The region of space from which light has had time to reach us so far during the 13.8 billion years since our Big Bang. So within here, we have hundreds of billions of galaxies, each of which has hundreds of billions, maybe hundreds of billions of solar systems. So it's big, really big. But look how much potential. Now, the more I learned, though, about the size of things, I have to tell you a personal story here of my sort of emotional journey through this. The more I learned about the vastness of things, the more insignificant and small I started to feel that I was and that all of humanity was. until more recently I actually made an emotional U-turn that I want to share with you folks, because even though we heard references to science fiction earlier today, and it's hard to watch any kind of Star Wars episode without getting this idea that our universe is teeming with all these other civilizations, some of which are far ahead of us. We actually have not a shred of scientific evidence for that being the case, and we have a mounting body of scientific evidence against it, actually, supporting the evidence that life is so rare that maybe the nearest other civilization that's invented the internet or telescopes might be outside even of our observable universe. So suppose for a moment that that's true. Are we really insignificant? Think about those galaxies we looked at. I think they're beautiful. But why are they beautiful? There's nothing in the laws of physics that says anything about beauty. They are beautiful because we, with our consciousness, experienced them, and we looked at them in our telescopes. There's nothing about purpose and meaning in the laws of physics either. So rather than feeling small and insignificant and sitting around waiting for our universe to give meaning and purpose to us, no, let's realize that it's the other way around. It's us giving meaning to our universe. And let's celebrate that. And let's be ambitious and create more of this sort of meaning. Because if this is the only planet that has telescopes even, then if we do something stupid with our tech and go extinct, the whole universe goes back to just being meaningless, a gigantic waste of space. And boy, what a bummer that would be, right? Another reason why I started to feel small and insignificant was because of time. Because I felt no matter how many vitamins I eat and how much I work out, if I live 100 years, what's that compared to 13.8 billion years? But actually, this is an incredibly special time. If we're alone in our universe, then this is the first time after 13.8 billion years when life has advanced to the point where it actually is on the verge of having the technology sufficient to either go extinct or spread and help life flourish throughout the cosmos for billions of years. So we're at this incredible fork in the road. Which way are we going to go? I think a good chance it's going to be decided on this planet, in our lifetime. But, so suddenly I hope you're feeling a little bit more pumped up here later in the day, feeling that maybe you're not so insignificant after all. And you are a lot more significant even than the average person, because you have so much influence about what's happening with our technology in our world. So I hope you take this as a sort of caffeine substitute to get pumped up and go out and make a difference. Now, so I want you to think big. I want you to feel that we are not insignificant at all here. Let's see a little bit what other people think about this. We did a survey recently asking about 15,000 people what they thought, and most of them actually said they want us to go ahead and build superintelligence. Almost all of them wanted us to be ambitious and help life spread into the cosmos. But now you might, again, get kind of sad and be like, oh no, but yeah, it would be so cool, but it's not going to happen for thousands of years. But I think that's actually an unscientific mistake. Wouldn't it be cool, for example, if we could, if you're feeling a bit crowded here in the Bay Area, if you could have a second home maybe somewhere else in the solar system, maybe in one of these rotating O'Neill cylinders where you get nice artificial gravity and you get a nice 24-hour night and day cycle, thanks to a clever system with mirrors and so on. But surely that's going to take thousands of years, right? Well, if we have to figure out all the technology, invent all the technology ourselves with our intelligence, and we have to build it all by hand. But that is so old school. That's the whole point of artificial general intelligence. If we can build it, we can amplify our own intelligence and have it do so much of the heavy lifting, and take a lot of these things which we used to think were centuries or millennia in the future, and actually have them happen perhaps quite soon. Perhaps not very long after we get superintelligence. What if you want to go somewhere else? It's another solar system. Even the nearest one was 3-4 light years away, and with today's rocketry we can't even get there. And if you get there after a few thousand years, you're probably going to not feel so great. But, if we can build AGI, we're not going to be limited anymore by our own intelligence, but by the laws of physics. And they are not very limiting at all. Even human intelligence has come up with clever solutions for getting to the nearest solar system, within a matter of decades. You can have AI powered robots build a very powerful 26 terawatt laser in orbit around the sun where it gets its energy, send out a nice laser beam, and push this spacecraft to the Alpha Centauri system where it can get and even land gently, in 20 years or something like this. In fact, it feels even less to you because of Einstein's relativity theory. What about going even farther? What if you want to go to other galaxies? This is something where I think science fiction authors have been way too pessimistic, because we are limited by the speed of light. This is our nearest neighbor galaxy, the Andromeda galaxy. It takes 3 million years to get there, even at light speed. And who wants to be like a meat bag in cryosuspension for 3 million years? It sounds boring. But here again, I think we have been too limited in our thinking. If you really reject carbon chauvinism and accept the idea that intelligence and consciousness are all about information, all about information processing, then no meat bags are needed. What's important to me is not my particles, but the pattern in which they're arranged. It's all information. And that's all that has to be sent there. If we've already sent some AI-powered probes earlier to build a little base, if you just want to send a copy of yourself, your DNA, as we heard earlier, from someone, only requires about 2 gigabytes to store. So you can store 100 of your buddies on one of these devices you can buy from a company near you and send it by intergalactic email for reassembly with error correction. And if you want to send all of yourself, by which I mean all the memories and personality traits and everything else is stored in your brain, that's about 100 terabytes, which used to sound like an awful lot when I was a kid, but now I just realized it's only 50 of these. It's 100 terabytes for you. So think big, okay? Not only does life have a great potential in the cosmos if you want to do, but it can even be human life. Now, where it gets trickier is, if we get superintelligence, who or what should be in control? Here there's much less agreement in our poll. And I was kind of amused to see that there are even about 10% here who wanted to be just machines, feeling pretty misanthropic. And there's total disagreement about what the role of humans should be, even at the most basic level. So let's take a look at some options that we could choose to steer towards, okay? And don't get me wrong, I'm not talking about space travel here now, despite all my geeky space talk earlier. I'm simply talking about our metaphorical journey into the future with artificial intelligence, all right? So, some of my AI colleagues want us to build superintelligence and keep it under human control, like an enslaved god, disconnected from the internet and used to create unimaginable technology and wealth for whoever controls it. But Lord Acton warned us that power corrupts, and absolute power corrupts absolutely. So you might worry that maybe we humans just aren't wise enough to handle that much power. And also, aside from any moral qualms you might have about enslaving superior minds, you might worry about that the superintelligence might outsmart us, break out, and take over. But I also have colleagues who are fine with AI breaking out and taking over, and even causing human extinction. Yeah. As long as we can think of the AIs as our children, as our worthy descendants. But how can we be sure that the AIs have adopted our goals and values and aren't just unconscious zombies tricking us into anthropomorphizing them? And also, shouldn't those people who don't want human extinction have a say in the matter too? Not just some gung-ho tech nerds. And if you didn't like either of those two high-tech scenarios, though, it's important to also remember that low-tech is suicide in a cosmic perspective. Because if we don't go far beyond today's technology, the question is not whether humanity is going to go extinct. The question is simply whether we'll first get taken out by a dinosaur-class killer asteroid or some other calamity that better technology could easily have solved. So how about having your cake and eating it with superintelligence that's not enslaved, but that treats us well, because we've figured out how to align its goals with ours. This is the gist of what Eliezer Yudkowsky likes to call friendly AI. And if we could pull this off, it could be awesome. It could not only help eliminate all negative, sorts of negative experiences like poverty, disease, and other suffering, but it could also give us the freedom to choose between this amazing new diversity of positive experiences, and really making us the masters of our own destiny. So in summary, our situation with technology is complicated, but the big picture, the really big picture, is rather simple. Most AI researchers expect us to get AGI within decades, and if we just bumble into this unprepared without any planning, it's probably going to be the biggest mistake in human history. Let's face it. It could enable brutal global dictatorship with unprecedented inequality, surveillance, and suffering, and maybe even human extinction, simply because the technology is so powerful that one mistake could be one too many. But if we steer carefully, we can instead end up in an amazing future where everybody's better off. The poor are richer, the rich are richer, and everyone is healthy and free to live out their dreams. But hang on, what sort of future society are we talking about here? Do you folks want a very strict, pious society with rigid moral rules, or do you want more of a hedonistic free-for-all like Berkeley in the 60s, or Burning Man 24/7? Well, or do you guys want beautiful bays and forests and lakes, or do you want to rearrange all these atoms into machines creating awesome virtual experiences? With friendly AI, we can simply build all of these futures and let people choose which society they want to live in, because we're no longer going to be limited by our intelligence, just by the laws of physics. So the resources and the space for this will be astronomical, literally. So in summary, here is our choice. We can either choose to be complacent, just take as our new religion this naive idea that all new technology is automatically going to be beneficial, and just repeat this over and over and over again as some sort of mantra as we drift like a rudderless ship towards our own obsolescence. Boring. Or we can be ambitious, thinking hard about where we want to go with our technology and the whole strategy of how to steer it in that direction to create a truly, truly inspiring future. In other words, we've been hearing here today all these fantastic ideas about accelerating intelligence. We all agree that we're accelerating. What do we want to accelerate towards? I would really like to accelerate towards a future that we have thought through a little bit in advance and are excited about going to. In other words, I would like to accelerate towards a future where we make artificial intelligence not that overpowers us, but that empowers us. Thank you.
Awesome. Thank you, Max. That was really inspiring and definitely stimulating. I definitely like that future of being ambitious and everybody happy and better off. I think that's certainly a great goal. This morning, I had said that this evening when you walk off from here, hopefully you'll have insights into what's in the future for us, and also that we all will know what we need to do collectively to get there faster. And certainly we got inspired with respect to not only AI, but AGI and superintelligence. So I'm sure as we are all driving home today, we'll definitely be thinking about what does superintelligence ultimately mean. Thanks a lot, Max. Let's give him a hand again. I also want to thank all of our speakers today. I would like to thank Prem and Lily. I would like to thank David Kirkpatrick for holding excellent panels. You are definitely signed up for our next event as well. Also would like to thank Keith Premal, and Tom. I think very inspiring panel there. And also Vijay and Simon. I also want to thank the speakers from Micron, Sumit, extremely inspiring talk, and Linda, really thank you for sharing the technology vision of Micron, as well as sharing personal story. Great to see that Connor is doing well. Yeah. So we all heard that AI is everywhere. We saw examples of AI in business, certainly heard a lot about AI in health. It's just mind-boggling, fascinating how rapidly those advances are taking place. We heard about AI in automobiles and data centers on wheels. So tremendous opportunities, AI absolutely everywhere in all businesses as well. We also heard almost from every speaker that AI is just in the very beginning at this point, right? This is barely starting. And this is where we see tremendous opportunity. You heard from Linda that we are absolutely AI ready. When we look at AI, it will touch every aspect of our end markets soon. It's starting to. Today, you heard it's a lot more about training. Inference is building up. Training is more in the cloud. Inference will be more on the edge, as well as there will be inference in the cloud in data centers. And all of this will certainly drive tremendous growth of semiconductors. AI within semiconductors, by some estimates, represents only about 2% of total semiconductor industry in 2018. By 2023 timeframe, by some estimates, it's supposed to represent approximately 20% of semiconductor industry. So AI will certainly be driving massive growth within the semiconductor industry. And it will be driving a growth of about 10 times of memory and storage, that is, in terms of revenue that's in semiconductors today, going towards AI applications, and it will be 10 times bigger by 2023 timeframe. So this is tremendous opportunity for all of us. We are definitely AI ready. We look forward to working with our customers, with our partners, and with all of you in terms of absolutely looking at all the opportunities to get there faster. I want to also congratulate the Berkeley AI Research Lab, AI for All, as well as Stanford Precision Health and Integrated Diagnostics Lab. These are all amazing institutions. Micron Foundation is proud to partner with you. And now, downstairs, I really want you all to go down there. There are amazing experience zones that will show you how things are already becoming real in terms of AI in life, AI in business, as well as AI in health. Really, you must not leave here without experiencing those. And of course, there is good drinks and food down there as well. So look forward to engaging with more of you downstairs. Thank you very much for being here today.